Sir, good morning, sir. JD sir.
Very good morning, madam.
Good morning, madam.
Welcome to this international webinar, sir.
Thank you, madam. Thank you.
Good morning, sir. Good morning,
Good
JD garu. Ravi, good morning.
All of you, good morning, sir.
Yeah, good morning, Jagannath garu.
Good morning, madam. Good morning, sir.
Okay. So now I'm sharing.
Okay. Yeah, Dr. Ravikumar sharing. It is sharing.
Okay. My presentation is coming now.
Yeah. Okay.
Yes,
Okay.
Shall I start or you have to?
No. You have to stop sharing first. After few introductory remarks, thereafter you will continue. Good morning, all of you. Good morning to Dr. C.H. Krishna garu, Giant Director of College Education, Dr. K. Bhagyalakshmi, Principal of my college, Head of the Department and Vice Principal of this college, Srimati P. Sailaja garu, dignitaries, resource persons, academicians, senior faculty members, special invitees, scholars, students, and everyone. Good morning, all of you. SRN Senior Government Degree College, located in Vijayawada, Andhra Pradesh, is a beacon of educational excellence with a rich history and prestigious patrons. The college was reaccredited with A grade in the 4th cycle of NAC recently. And also, autonomous status was extended by UGC for 10 years up to the academic year 2032-33. The college enriched with modern facilities and infrastructure, including recording theater, AR/VR laboratory, computer labs, virtual labs, digital classrooms, and well-equipped science laboratories. The college administration is committed to the student employability. It hosts job fairs and recruitment events through its Jawahar Knowledge Center. The college is committed to improve the quality of teaching and evaluation in an institution, and hence conducting so many teachers and training programs, seminars, webinars, workshops, along with evaluation reforms using artificial intelligence. With a focus on academic excellence and community impact, SRN Senior Government Degree College continues to shape the future leaders of India. It is a great opportunity to associate with you all who joined in this international webinar, advancements in nanotechnology for building safety, electronic devices, and magnetic sensors, with eminent resource persons from various world-class universities and institutions. So the resource persons are, one of them are Professor K. Ravikumar Kedrala from South Korea. He has 22 years of research experience in various research fields of multi-step organic synthesis, triboelectric nanogenerators, and biometric actuators, flame retardant nanofilters, organic coatings, organic synthesis, functional graphene, nanoparticles, nano surfaces, and solar cells, metal organic frameworks, and nanocatalysis. And one of the eminent resource person from IIT Guwahati, Professor D. Pamu, is one of the has greatest rich experience in research and innovation. He has experience in high K and low pass filters and ferroelectric and piezoelectrics, bioceramics, microwave ferrites, oxide thin films, nanomaterials, and semiconductors. This is the research field of Dr. Pamu, IIT Guwahati. And third resource persons are Dr. Pratap Pallu, they are Assistant Professor of Physics, University of Hyderabad, Telangana. Their research experiences are magnetic sensors and materials, multiferrics, water purification, and lithium-ion, sodium-ion battery anode materials. I welcome the above resource persons to encourage the faculty of various colleges and university faculty, scholars, academicians, students participating in the webinar. The officials of the Commissioner of College Education, Dr. Pola Bhaskar, IAS, Commissioner of College Education, Dr. Sage Krishna, Giant Director of College Education, and all others are encouraging in all aspects in teaching, learning, and evaluation. And thankful to the organizing secretary, Dr. Ashirvadan garu, and my department faculty to conducting this seminar. And thank you very much, all of you who are participating in this program. This is from IKC coordinator Dr. J. Nageshwar Rao, SR and CVR Government Degree College, Vijayawada. Now I welcome Honorable Joint Director of College Education, Dr. C.H. Krishna Garu, few remarks on this international webinar. Welcome, sir. Welcome, JD, sir.
Good morning, all the dignitaries, eminent academicians, senior faculty members, nodal resource persons, special invitees, scholars, and everyone. College education giving special attention to provide holistic platform for students and teachers to develop 21st century thinking skills, moral values, and leadership qualities for building a futuristic nation. To achieve above goals, Commission of College Education upgrading the institutions as quality centers through continuous monitoring and guidance. Student-centric teaching through capacity building of teachers by providing eco-friendly and skill-oriented campuses for holistic blooming of body, mind, and soul of the students. About research, to create a conducive environment for enhanced research productivity, Commission to College Education is encouraging collaboration across industry, government, community-based organizations, and agencies at the local, national, and international levels with colleges. Faculty development programs, FDPs, building the capacity of the faculty and student in line with the latest advances in diverse disciplines to push the boundaries of knowledge and contribute to technological developments relevant to social needs. It would also pave the way for higher education institutes to attract more research grants under norm-based funding, improve its accreditation ranking, and enhance its brand image. Regular events such as research courses, workshops, trainings, internships, group discussions, and seminars, conferences may be organized for capacity building. RDC would play a pivotal role in creating central research and development facilities with the provisioning of associated training internships thereon. About the webinar, the Department of Physics and Electronics of SR and CVR Government Degree College Autonomous, Vijayawada is organizing an international webinar on nanotechnology. For this event, 3 eminent resource persons were chosen across the globe. Nanometers are essentially engineered at the nanoscale. 1 nanometer is equal to 10 to the power of minus 9 meters, where particles are typically 1 to 100 nanometers in size. The minuscule size grants them unique properties compared to their bulk counterparts. Due to their exceptional grain size, refinement, nanometers boast significant enhanced mechanical properties like strength, hardness, and wear resistance. Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors. Information technology, homeland security, medicine, transportation, energy, food safety, and environmental science, among many others. Described below is a sampling of the rapidly growing list of benefits and applications of nanotechnology. All the best. All the faculty members, teachers, and students are requested to enhance your research skills by utilizing this webinar. I would like to thank Principal Kodali Bhagyalakshmi Garu and Physics HOD Nageshwara Garu for inviting me to this international webinar. Thank you all once again. Thank you.
Thank you very much, sir. Always we remember you, sir. But viewers support from not only in the JD cadre, in previously RJD cadre also, you helped me more. Thank you very much, sir, for your special guest remarks. Now I request precious remarks by Dr. K. Bhagyalakshmi Garu, principal of this college.
Yeah. Very good morning, one and all. Honorable guests of today's international webinar, our Chief Patron, Dr. Pola Bhaskar IAS, Honorable Commissioner of Collegiate Education, and our special guest, Dr. C.H. Krishna, Joint Director, Commissionerate of Collegiate Education, and the resource persons, Professor Ravi Kumar, Adjunct Professor and Principal Scientist for NRF, Changwon National University, South Korea, and Professor D. Ramu, Department of Physics and Center for Nanotechnology, Indian Institute of Technology, Guwahati, and Professor Pratap, Center for Advanced Studies in Electronics, Science and Technology, and School of Physics, University of Hyderabad, and participants from various educational institutions of different countries, faculty members of various disciplines, scholars, and my dear students. On behalf of SR and CVR Government Degree College Autonomous Vijayawada, we extend a warm welcome to this international webinar on advancements in nanotechnology for building safety, electronic devices, and magnetic sensors, organized by Department of Physics, SRR College. This college has been established in 1937 with its vision and mission and with a slogan, Karanena Adhyayanam. And SRR College is playing a pivotal role in creating research thrust in students and staff by conducting international webinars, conferences, workshops, field trips, and guest lectures with eminent scientists. And with the support of our Commissionerate of Collegiate Education, we are conducting many training programs for the capacity building program of our college. And in this connection, today, the Department of Physics is conducting this international webinar. As our college is an autonomous institution, Department of Physics is supporting us in many ways. Vice Principal, IPSC Coordinator, NIRF Coordinator, TLP Coordinator, and the Timetable Committee will come from that department only. Coming to the topic, the whole world is roaming around the nanotechnology. Nanomaterials can be added to cement, cloth, and other materials to make them stronger and lighter. They have lots of applications in electronics and they are used in environmental remediation. Nanotechnology and its microscopic universe offer gigantic possibilities for contemporary science and industry. This is converting the global market as global nanotechnology market. So, nanotechnology is working for the welfare of human being to improve the human health and to protect our environment. Many scientists are working on this, and today we have three eminent scientists with us to discuss all these issues. I congratulate the department in charge of physics, Ms. Sailaja Garu and her team, and organizing secretary Dr. Ashirvadam for their efforts in bringing scientists from IITs, central universities, and national universities. Hope you will have a fruitful discussions and may God Almighty open many new ideas in innovation and research.
Yeah.
Thank you so much.
Thank you very much, ma'am. Always without your guidance and support, we can't do anything. Thank you very much for this presidential remarks. Now I request head of the department and the vice principal of this college, Srimati P. Sailaja Garu, as the their convener remarks.
Respected today's chief guest, Joint Director of CCE, C.H. Krishna Garu, respected the college principal madam Dr. K. Bhagyalakshmi Garu, today's resource persons, Professor Ravi Chedarala, Principal Scientist, South Korea, Professor D. Pamu Garu, IIT Guwahati, and Dr. Pratap Kollu, Assistant Professor, University of Hyderabad, Telangana. Good morning, sir. Good morning, all the dignitaries, eminent academicians, senior faculty members, notable resource persons, special invitees, scholars, and everyone. I am Mrs. P. Sailaja, in charge, Department of Physics and Electronics, SRR and CVR Government Degree College, Vijayawada. It's a great opportunity for me to be associated with you all who joined in this international webinar on advancements in nanotechnology for building safety, electronic devices, and magnetic sensors. Ours is the college premier institute of this region. SRR and CVR College was established in the year 1937 by Sri Raja Rangayappa Rao and Sri Chudduru Venkatareddy college is functioning under the aegis of by the Commissioner of Collegiate Education, Government of Andhra Pradesh. The campus is located at Vijayawada, approximately 6 kilometers from bus stand and railway station. The majority of the members of the faculty of the Department of Physics and Electronics are doctorates and pursuing PhD programs. The faculty have got research interests and published papers in many national and international research journals. The faculty members guide students towards the upcoming progressive scientific studies by conducting workshops and certificate courses regularly like robotics, preparation of nanoparticles, PCB design, Android cell phone mechanism, hardware and networking, etc. The Department of Physics and Electronics had MOU with Karo Sambhav through NGO Guide Foundation Vijayawada for zero waste recycling process. The Department of Physics and Electronics also started dry waste collection as an environmental friendly best practice in SRR and CBR Government Degree College Autonomous Vijayawada. Regarding webinar, advancements in nanotechnology for building safety, electronic devices and magnetic sensors. A prime nanotechnology example of an industry where nanoscale manufacturing technologies are employed in a large scale and throughout the semiconductor industry where device structures had reached the single nanometer scale. For smartphones, smartwatch, or tablet, all are containing billions of transistors on a single chip, which is the size of fingernail. Today, we learn more and more on advancements in nanotechnology. Thank you very much for giving this opportunity. Thank you, sir.
Thank you very much, ma'am. Because of physics department is giving more support to the college because of my head of the department, Sriman Sailaja Garu, and their leadership qualities. Thank you very much, ma'am, for this giving their webinar convener remarks. Now, before going to the first resource person presentation, I would like to introduce first resource person, Professor Ravikumar Chedrala, by our one of the senior faculty in physics, Srimati T.V. Bakulapriya Garu. Ma'am, Bakulapriya Garu, please introduce our first resource person, Professor Ravikumar Chedrala. Thank you, ma'am.
Thank you, sir. Good morning to one and all. Respected Chief Patron, Dr. Paula Bhaskar IAS, Commissioner of Collegiate Education, and Patron of this program, Dr. C. Krishna Garu, Joint Director of Commissionerate of Collegiate Education, and Chairperson of this program, Dr. K. Bhagyalakshmi, Principal of SRR and CVR Government Degree College, Vijayawada. It is my privilege to introduce our Indian scientist whose native roots are from a rural village named Chintalpudi of West Godavari district of Andhra Pradesh. Though he is from Telugu medium background, he achieved a higher position as a scientist in South Korean University with his hard work and dedication, and inspiring to many rural students like our degree college background. He is our today's resource person, Dr. Ravikumar Chedarala. He did his PhD in organic chemistry at Jawaharlal Nehru Technological University, Hyderabad. He did MBA in Import and Export Management in National Institute of Business Management, India. He did PG DPM Management in Hyderabad Central University. He also did his MSc Tech Chemistry in JNTU, Hyderabad. He had 22 years of research experience in various such fields of multi-step organic synthesis, triboelectric nanogenerators, and biomimetic actuators, flame retardant nanofilters, organic coatings, organic synthesis, functional graphenes, nanoparticles, nanosurfaces, and solar cells, metal organic frameworks, and nano catalysis. Also, he is an adjunct professor and principal scientist to National Research Fellowship NRF project of South Korea. So far, he published 70 research articles in international peer-reviewed journals and 7 book chapters. He had done 6 projects from the year 2003 to 2024. He has completed government TIPS program, that is private investment led technology startup support in South Korea. He has all over teaching and industrial experience of 23 years from 2001 to present year. He is volunteering as a journal reviewer. Up to now, he reviewed around 115 research articles. He attended for 25 international conferences and he evaluated 4 PhD thesis works as a co-guide, and he delivered 16 international talks in various forms. He was invited as a keynote speaker for 6 conferences. He got 2 international awards and he worked as a senior manager and chief scientist at Yangsang Co. Limited, Ulsan, South Korea in 2008 and 2009 years. During 2001 to 2003, he worked as a staff scientist at Dr. Reddy's Labs, Hyderabad. He is also interested in traveling and he have social responsibility. He is interested in cultivation and he also used to collect different types of plants from different places. He has much passion in teaching. Often he used to play badminton in his leisure time as a hobby. With this introduction, I invite Dr. Ravi Chedarala Garu to deliver his lecture. Thank you, sir.
Thank you very much for your kind and great words about me. I'm really happy to share my knowledge of what I gained since last 20 years and 22 years. So this is a great honor for me to meet you all, especially in Andhra Pradesh, very close to Vijayawada. And I thank to Ola Bhaskar Garu, the AS, the Joint Director of Education, and other team, especially my closest friend, Mr. Nag, Dr. Nag. He is my benchmate during my until 10th class. And after that, we bifurcated. I went to BPC and he went to mathematics. Thank you. Thank you very much. I'm going to give my lecture based on instrumentance fire retardancy property attained by multifunctional hydroxyapatite nanoparticles decorated on jute fiber mat. So this is a very simple work. I wanted to emphasize because hydroxyapatite everywhere we can find. You know, it is a phosphate material. This is gained by the animal bones where we throw after eating the meat. So these bones are used for making of hydroxyapatite nanoparticles. This is almost get rid of material, but I wanted to sustain the material for the asset of various nanoparticles. I hope you are seeing my slides.
Yeah, okay, okay. Okay, Ravi.
Now,
Yes.
already, Professor already introduced about me and my research areas, where I have active research areas of multi-step organic synthesis. This was uh, learned in during my PhD course at JNTU, Hyderabad, and pharmaceutics. This I was learned from Dr. Reddy's and nanocatalysis for organic functional group transformations, artificial biomimetic, sensory organs, triboelectric nanogenerators of both solids and liquids, organic solar cell materials, thermal conductivities and critical heat flux of nano liquids for the heat engines of the four-wheelers and heavy vehicles, even for trains, and nano coatings for instruments of fire retardancy property and hydrogen production from solid cell fuel cells and electrolysis. This is my present core research area where I am working for the hydrogen production. You know, the hydrogen production is the future of everywhere on the globe because the sustainable green energy is very important because the fossil fuels are gradually depleting. So for the next 2, 3 generations, we don't get any petrol and diesel because we already consumed many things. So to overcome that, the scientists like me, we are working on hydrogen production from solid cell fuel cells and electrolysis process. And already, Madam told about my experience and my publications in the introduction part. Now I'm going to the real research area where we can introduce about the instruments fire retardant material. Introduction and history of flame or fire retardancy. What is instruments flame retardancy? Instruments flame retardant form a stable foam layer on any part of the material that can barrier to not penetrate the oxygen to catch the fire. So that is called combustible material. This combustible material will be stop the flame to catch and to enhance the fire on the surface. So, what is the history of flame retardant? Flame retardant materials were first created around 400 BC, but the need for them did not increase drastically until 17th century. Nobody touched about that research because it's not needed during that time. But after industrialization and the people greediness, this technology has been replaced in the present scenario. So, who invented the flame retardant fabric? So, Abia Vaide in 1735, who used sulfate, alum, iron, and borax to treat the fabrics. And this work was continuously worked for the French chemist Joseph Gay-Lussac, who did significant research into the flame retardant material. So, what is the need to do this research? Because the scientists always thinking about the novelty and what is the help to the society. The society is very important to live for everyone and equally enjoy the society. But some of the problems we still facing. So, to overcome those problems, fire accidents are major concern nowadays. The fire accidents occur due to human errors, natural disasters such as heat wave generation. Because this is the summer in India, so everywhere in Vijayawada, the temperature is almost reaching to 40 or 42. I am observing every day. And generating during summer, volcanoes and tsunamis, these are the natural disasters we are facing, humankind. And the transportation systems of aeroplanes, trains, cruise ships, and domestic vehicles often suffer from fire accidents because of the fuel mishandling and short circuit. These things are happening. And fire accidents often catch fire in industries, especially multi-story buildings, gas cylinders, and interior decorations such as wallpapers, interior cloths, and false ceiling. This is the serious problem in multi-story buildings like Hyderabad and Vijayawada everywhere in New Delhi. So we often find this kind of accidents during uh, accident-prone areas, and we are listening in the news. And who invented the next, fire accidents often catch fire, and also to overcome these abrupt accidents, nanotechnology is the alternate method, and it is a potential alternative to stop or to delay the fire burnings and save the assets through fire retardancy property. So, note, for example, if you find how many deaths are observing every year, 1,20,600 people are generally dying due to the fire accidents around the globe. You see the short circuits, prime causes you can find here, and fire accident due to plastic usage near current carrying parts lead to the search for flame retardant plastics. The plastics are alternative material for developing the flame retardant materials. So to incorporate such materials, so we have to research on that. And also number of deaths due to wildfires worldwide from 1990 to 2003. You can also find here year-wise from 1990 to 2022. People are almost more than hundreds have been died due to the wildfires because we cannot control them in the overnight. So to overcome these problems, we working on continuously to develop a nanotechnology. Those are really work on the surface as a combusting layer. So you can see here recent accident in Hyderabad. You can enjoy this video.
Officials said the fire broke out at the Ruby Electric Scooter showroom on the ground floor of the building and soon spread to a lodge that was located on the first and second floor, killing 8 people. Around 25 people were present at the lodge when the fire broke out. The fire department rescued several lodge residents using trained ladders.
Okay. So this is the only indication what we are doing in the society, how we are mishandling the tools to survive in the society. And you can see the plastic and flame retardancy. This is the key slide for to understand from 2000, from 1950 to the present scenario. Till 1950, the natural choice is thermosets, metal-like materials we use. But later, we developed a new material that is called PVC, polyvinyl chloride, and flexible neon insulation materials. Later, 1965 to 1980. So we replaced the new polymeric materials that is called self flame retardant polymers, that is polyacrylonitrile, polycarbonate, PTFE, and lots of FR maintenance compounds are developed here. And since 85, so we FR compounds mainly focus on the FEC, expert, and metal oxides. These are very cheap, and also they can be stop the fire extension when the fire catches on the any material. So here you can also observe the limiting oxygen index. What is the limiting oxygen index for the FR measurement, flame retardant measurement? So this is depends on the penetrating of oxygen in the material that can catch fire and extend the fire for until it burns a last piece of or last atom of the material. So to overcome that, the LOI percent we have tabulated here. The plastics, you see here polypropylene, polyethylene, polystyrene, and PMMA. These are having the LOI is 18%, ABS is 19%, PBT is 20%. The atmospheric oxygen content is around 21%. That's why it will catch immediately the fire. And PS66 that is showing LOI is 24, and the PC polycarbonate is 27, PVC is 42. The PTFE, also commercially known as a Teflon, that shows maximum of LOI that is 95%. So the Teflon cannot catch the fire because the oxygen cannot penetrate into the material of the PTFE. So this is the toughest material, and that can be survived in the humankind. But the problem is the PTFE is very costly. We cannot buy for every normal people. So to overcome that, we are developing a nano material. That nano material we coat on different woods, and that can be save the life and delay the uh, limiting oxygen or fire catch. So here you can see the commercial successful plastic, crystalline, and amorphous materials. Here the extreme temperature plastics are you can see the first block, and the high temperature plastics are second block, and the engineering plastics that can be used for the flame retardancy in the third block. But the last one is PTFE and the PET. These are the materials can help to survive the humankind. And so these are the high performance engineering materials. They can be stop fire or stop catching the fire for the any particular origin. And also never newer flame retardants. So when we develop any flame material, we should concern about the environment and sustainability and regeneration. These are the key factors for the any scientist, because when you develop a novel material that can be shown here, you see industrial revolution, miniaturization, electrification of auto industry, and increasing potential of fire hazard, stringent requirements, standards, and regulations. Of course, you are the wizard of people. Autonagar having a lot of several problems because these are the problems they are facing. And here, the fire catching mechanism you can find here. When the catch fires on the surface, it will be decomposes on the surface area, and automatically the combustion will be started, and the gases will be generated from the surface like carbon dioxide, carbon monoxide, and sulfur gases and methane, like that. Whatever the material it has made by different compositions, those releases the elemental oxygen also releases from this. And also when heat is generated on the surface, it will be converted into gas phase. The gas phase is mainly thermal feedback. The oxygen is playing a key role. As I said, it is available 21% in the environment, that is immediately catch wherever it is fire is started. And the heat combustion production also you can find later, the find you can find the smoke from the surface or origin. So that char layer will be destroyed, whole the setup or whole the uh, belongings which catch the fire. So why flame retardant is very important? This is very known to understand by the students or scientists or professors. Mitigate fire danger, contribute directly to the saving of lives. So this is very key factor to understand the fire retardancy. So it slow downs the polymer combustion and the degradation, fire extinction of the reduces and reduce smoke emission, avoid dripping, prevent the fire or retard its growth and spread the flashover from the surface, and protect occupant from the fire effects and minimize the impact of fire. So here you can see the two graphs. You can find without fire retardant and with fire retardant how the heat flux is moving on the surface. You can see from 0 to around 7, the heat flux is gradually increased in 2 minutes. But when we use fire retardants, the heat flux is gradually reduced. Even after 20 minutes, it is started firing. Its catch the fire is very less. It means during 20 minutes, we can easily escape from the debris area. Or, and also we can also save our assets or important documents from our uh, cabinets and whatever it is important that is easily removed from the original place where the catch fire. So the heat flux is very important. Also, you can see the heat flux that is measured by kilowatt per meter square. You can see from 200, it is the flash continuously flowing. So that is the material without fire retardant deposited material. After deposition of fire retardant, it is gradually increased at the time, and the flashover also gradually decreasing from time to time. So you can observe this graph from 200 seconds and 400 to almost 1000 seconds. The gradual flash extension is gradually reducing because of the deposition of flame retardancy material, that is the nano material on the surface. You can observe this video, the flame retardant material, how they developed from Australia and how they use. This can be understandable and also for the known to everyone. So please listen this video. So this scientist is depositing the flame retardant material on the wood house and focus the jet of heat or flame. So without flame retardant material, the wood is completely burned out. But in the case of flame retardant material deposited on the other cabinet or other house, it doesn't caught the fire because the flame retardant surface is sees the fire to penetrate inside of the wood. So this is the important development recently has been done by the scientists from Australia. And also you can see the development of the carbon layer on the wood house, that is the uh, saving of our life, and he is commercializing this nanotechnology based on the flame retardant paint. That paint is available everywhere in the globe, so we can also apply. In India also, people are developing this kind of technologies to save the people and society and assets. So coming to my original research, so here this work is recently published from Royal Society of Chemistry. The journal name is Materials Advances. So this was published in 2023. It is called Renewable Microhydroxyapatite extracted from animal bones and fabricated as MHA jute vinyl ester biocomposite as an insufficient green flame retardant material. So this material is very important, and also this is very cheap. As I said, this is a get rid of material I used for making of this nanomaterial. This nanomaterial known as microhydroxyapatite. Hydroxyapatite, nothing but our bone material that is made up of phosphates. And here, the renewable hydroxyapatite extracted from animal bones, fabricated as MHA jute vinyl ester biocomposite as an instrument green frame retardant material. So here, this paper is mainly we developed in two different kinds. One is directly deposited on the surface of the jute, and other one is we developed on the surface, and that jute we used for the panel to use for the industry. That is, that panel is made of vinyl ester panel. That vinyl ester panel is made with jute after deposition of flame retardant material, and we tested the flame retardant activity before and after of the vinyl ester deposition. So these panels are very important, and we use the heat release rates. Also, we tested on pure jute and MHA jutes, that 1 weight percent, 2 weight percent, and 3 weight percent. We stopped at 3 weight percent because if we increase further, the brittleness will be increased for the material. And also the secondary stages also we studied here. The HRR means heat release rates gradually decreased from pure material is showing 177 to 3 weight percent of MHA jute showing only 388%. It means it is already increased 2.5 times of the heat release rates. It means it is strong withstanding material for the usage of industry applications. The HRRs of MH jute VER biocomposite showed superior thermal shielding action over the blank TJVER biocomposite. Also, we studied pure jute with vinyl ester resin biocomposite without addition of the vinyl ester resin of hydroxyapatite, and after addition of the hydroxyapatite, what is the results we studied here, and also the heat releasing rates we can study here: 291 seconds, 131 seconds, and 41 seconds. So the 291 seconds showing maximum extension of the field, fire is not catching during that time. But in the case of pure jute with vinyl ester resin, that shows just in 41 seconds it is catching the fire and it is completely burned out. So that we studied here with 1 weight percent, 2 weight percent, and 3 weight percent of MHA deposited on jute, including with VERs, that is called due to the formation of thermal shielding on the surfaces. Those are the important factors here to understand the technology. And higher burning times and burning rates were reported through this material and through this composite, and also limiting oxygen index also we controlled using 3 weight percent of MHA jute VER composite. Moreover, ignition resistance and self-extinguishing complete competences were observed on coated fabric. That fabric means pure jute. You can understand here. And after deposition of 3 weight percent MHA jute also showed a great advantage, that is used for indoor fire quenching application, like you can use for the door curtains and window curtains, and also for the door mats or bed sheets, something like that. So the experiment is how we made. This is important for the learning students. Here, the synthesis of microneedle hydroxyapatite in the stage 1, and stage 2 dip coating of MHA on jute fibers, and stage 3 showing fabrication of MHA jute biocomposite via VAR-TEM method, and stress strain curves also we studied through this slide. Here you can see the bone, and we decompose it by NOH, strong NOH, like 28% of NOH we took. And after 20 days, it was converted into suspension. That suspension we dried. First, we before drying, we treated with hydrochloric acid and dried, and later we make into the powder. This is called dry MHA. This dry MHA we again sintered for 2 hours at 1000 degrees Celsius, and we got the clean powder. This is called a calcinated powder of MHA. This calcinated powder showing FSM, that is clearly very crystalline, and it shows the micro hydroxyapatite. That's why I gave the name as MHA. So later we go into the dip coating on the fabric. We took the different weight percentage of the MHA in the ethanol or any suitable solvent, and we make into the stirring. After stirring the uniform liquid, and we take that liquid and dip the jute fiber. That jute fiber is deposited for almost 4 to 5 hours. So we leave for them, and later we take out and dry the material. Later deposition of FR related or deposited material, you can show the surface on the jute fiber. You can find white material, that is the deposition. Actually, and the sum is showing very clearly, and also heat releases of MHA jute is very clear. So here I will explain in the next slide, because this is only the overview of the material. And also I told you we made pure jute panels with vinyl ester resin before and after deposition of flame retardant material, and also we checked the surface and quantities and flame retardant technology here. And here, how we make the synthesis of MHA jute from cellulose in jute and MHA using dip coating method via ion-ion electrolytic or electrolytic chemical modification. Micro hydroxyapatite, the chemical formula looks like this, the chemical structure. It has a chemical temporary bonding with the calcium metal. That calcium metal is deposited by or bonded with the phosphate groups. Those phosphate groups again uh, binding with the calcium metal. This is repeatedly happening. So this is the structure of the microhydroxyapatite, and we deposited this material using a solvent, and that is called cellulose and jute. Means this is a pure jute material. The structure looks like this. These hydroxy groups are strongly binding on the surface of jute with the microhydroxyapatite through electrolytic bonding, also ion-ion electrolytic chemical bonding. After bonding, this material looks like this one. This is the deposited material, which is showing chemical formula like this. This is the MHA jute. So after this is the pure jute, and this is the FR material that is called MHA. After deposition by dip coating, we got the combined material. That combined material looks like this polymer. This is a natural polymer, also known as MHA jute. That's why I designed this material to understand and to reduce the flame retardancy, to increase the flame retardancy property, and to reduce the LOI. And also you can see the other way to maintain the experiment 3, preparation of MHA from raw material, that is called raw animal bones via base acid treatment. So first you take the animal bone. After conversion, it is powder. This is a nano powder. Sometimes it is micro powder. So after treatment with NaOH for more than 20 days, and it was decayed uh, due to the hydroxy groups, and it formed the slurry. That slurry again treated with acid to make into the neutralization, and this is at the pH 7. And later we finished filtered and dried. And after drying, we can make the sintered for 2 hours at 1000 degrees Celsius, and cooled and crushed and make into sieving at different millimeters and different size of the sieves, and we get the final the nano product. Is nano and micro product mixing at room temperature. This is very easy to make, and it is very expensive because there are several steps have been involved. And because I am a scientist, I know how to do that. So, but in the case of market, 1 gram of the material is almost $2. It means that it is very expensive. But the starting material is very cheap. But after several steps, the cost is increased. So we have to reduce that one using the bulk quantity. And also here, experiment 4, fabrication of MHA jute VAR biocomposite via VARTM. VAR means vacuum assisted resin transfer molding technology, where there is a vinyl ester resin. It was gradually passed through the panel. This is the panel we made with the jute fiber after deposition of MHA. So the resin is flowing in the forward direction because the vacuum is created from this side. So automatically the laminar flow happening on the surface. So EMHAJF is formed here. So the vacuum bag is we attached on the surface, and the resin is excess resin is trapped on the surface. Later, after completion of the panels looks like this. Before, this is the pure jute without any addition of flame retardant material. After addition of flame retardant material, you can find the flame retardant material on the surface inside of the material. So this is the panel, plastic panel. The plastic is vinyl ester resin. So 1 weight percent, 2 weight percent, and 3 weight percent of MHA we have incorporated on the jute, and we did VRTM method to pass on the jute from the VER composite material. So we analyzed the material, how it is really came on our parameters or not. We meet the real parameters or not. That we studied with the FTIR. And also we can see the phosphate groups on the surface. It means that phosphate is there means automatically MHA is deposited on the surface. And also there are CH2 groups. These are coming from the surface of the cellulose, and there are OH groups also coming from the cellulose surface. Already I shown in the chemical structure. The chemical structure is already having many OH functional groups on the hypenose group. That group is showing here. So the MHA jute, MHA powder, and the pure jute you can distinguish easily, and the phosphate groups and HPO4 groups are appear very clearly on the surface. It means that phosphates are there means automatically the surface is strongly designed by the phosphate groups. It means the deposition of MHA is strongly appeared on the surface. Next, we go to the crystallinity of the material. The crystallography of showing by XRD, the 2 theta degree are showing the crystallinity very strongly because MHA is already crystalline material. You can observe the pure MHA and MHA powder. You can easily distinguish the powder is blue, that is showing very crystalline. After deposition of the MHA on the jute, that shows very crystalline, that is a red signal. And you can see the black one, that is a pure jute. Pure jute doesn't have any crystallinity, so that is not very crystalline, and the peaks also not very good. So here the thermal gravimetric analysis also shows the decomposition of the material. The you can see here from 66 degrees Celsius to we went up to 500 degrees Celsius, and at 438 degrees Celsius MHA jute is not decomposed. But in the case of pure jute, it shows decomposition started from 90 degrees, 96 degrees to until 257 degrees. So it means 91 weight percent of the material is combusted completely and it became into the char. But in our case, MHA jute is showing strong withstanding of heat, that is started from 66 degrees, but it is just uh, 74% only withstanded. 61% is also withstanded at 438 degrees Celsius. At 696 degrees Celsius, it was decomposed only 56 weight percent. It means we prolongedly heated this material, then only it was decomposed slowly because the surface is shielded by the MHA. The MHA is stop penetrating of oxygen and stop penetrating of heat waves. That's why this is called heat release rate. We confirm here. Also, we tested the surface of MHA, that is some morphologies, and EDX analysis, elemental analysis. We also tested how many, what kind of elements are present in this material. We tested here at the particular area, that is micro needles. You can observe here. These needles are showing here. There are several elements you can find, but calcium is showing and the phosphate also showing here. So these are the two important functional groups obtained from the MHA. So you can see the signal of phosphate and carbon and other materials coming from the jute fiber, that is carbon and other instrument elements also coming along with this group. And there are some minor elements also found here, magnesium and calcium, potassium and oxygen. You also find sodium also you can find along with the original elements. And you can see the jute fiber mat when we take into the magnification, that is called the surface morphologies of images A to B, the showing the clean surface because there is no deposition on the surface of pure jute. So you can see these are looks like hairs and there is no foreign body on the surface. But in the case of C and D, you can find the deposition of MHA on the surface. So there are no toes on the surface you can find in these in the images of C and D. It means the dense deposition occurred after deposition by dip coating, that is 3 weight percent of MHA on PJA with dense depositions you can find in the FSM images. Also, we tested the vertical burning test of pure MHA jute biocomposite with against to the pure jute. So the pure jute is continuously burning within 15 seconds. But in the case of deposited material with MHA, after 60 seconds also the burning has not started. You can find here there is no catch fire on the surface. It means the MHA is strongly resisting heat waves on the surface and also the heat release rate is very high. So here you can see from the first group and the second group, the time you can find, it means that the introduction, when the introduction I explained, so we delayed the flame retardancy and we delayed the flame catch with the deposition of micro or nano layers on the surface of any material. It is only jute. We also studied for the cotton and silk, but that will be explained in the future. Also here the results, heat release rates you can find here with pure jute and MHA jute with different weight percents. Here you can see in the graph A, the graph A shows that pure jute is black one, that is heat release rate is 177. In the case of 3 weight percent of jute, that is only showing 36. It means 36 means almost it is 8 times lesser compared to the pure jute. The 36 is showing here. This is the highest heat release rate and it is showing very strong HRR, and the temperature also you can find here at around 250. It means that the temperature when increases, automatically the resistance also increases using of different weight percent from 0.5 to 3 weight percent. But we concluded only 1, 2 and 3 because we wanted to commercialize. We cannot supply all combinations. So we standardize only 3 out of from 6, that is pure jute along with 1 weight percent, 2 weight percent and 3 weight percent. Also, you can see the primary HRR and secondary HRR means we studied the heat release rates two times. One is the first time and second time. This is the first primary heat release rate and this is secondary heat release rate. This we studied only by instrument. We cannot study by directly by naked eye. So here also you see this is showing you can magnify this HRR, the primary heat release rate and secondary heat release rate. You can easily observe, and also this image B is showing very clearly the against of pure jute. And it means that we achieved the heat release rate is very high compared to the pure jute with 3 weight% of MHA on the jute. And the results too, you can see the digital images of fabricated pure jute, this one, and MHA jute with different weight%, like 1 weight%, 2 weight%, and 3 weight%. Also, you can see the biocomposites against to PG, that is impact energy. Impact energy means how this panel is very strong or weak, that we bombard with the heavy weight, and when it is broken or not, that will easily studied here. You can see the impact test. The impact test is showing energy joules per centimeter square. The impact energy for the pure jute is 2.2, but in the case of 1 weight% showing 2.7, 2 weight% is 2.8, and 3 weight% is weight% MHA jute is showing 3.22 times. It is almost 1 point, 1.2 times higher compared to the pure material. It means it is strong enough compared to the pure jute. And also tensile strength and stress also we studied here. So the black one 2.5 at 66, 3 and 3.2 and 3.4, it is almost double compared to the pure jute with the 3 weight% of MHA jute. Also, you can see here the PJ is showing 67, but in the case of 1 weight%, 72, 2 weight% is 85.3, and 3 weight% is 121. Means the strength is gradually increased in megapascals from compared to the pure jute. This is the tensile strength we studied in the results too. Also, this is the very important result, that is heat release rates. Image A and image B carries percent HRR and burning times and burning rates. It is the image C, and D is the LOI, limiting oxygen index, that is observed by PJVER. PJ means pure jute with polymer, that is called vinyl ester resin. I already shown you in the previous slide four panels. That four panels we studied here, where the heat release rate you can compare here. 712 means highest heat release rate, that is completely burned by the PJVER. But when increases the weight% from 1 weight% to 3 weight% of MHA on the jute VER, it is gradually increases the heat release percentage, that is 41 to 291%. It means almost you can easily calculate 6 times higher. And the percent HRR also compared to the PJVER, the PJVER is not showing anything, but in the case of 1 weight% to 3 weight%, it is increased from almost 0 to 291. So the same image I tabulated here as a graphical and two. And also you can see burning time and burning rate. The burning time you can see in the blue, and the burning rate is 42.8 and 20.4, and in the case of 3 weight% is gradually increased, and the burning rate also gradually increased. And also here you can see the biocomposites of PJVER 23.2%, and 1 weight% is showing 24.7. In the case of 3 weight%, it shows 29.5%. It means that the limiting oxygen index also gradually increased through biocomposites which made by the MHA jute VER compared to the PJ VER. So this image shows the mechanism of burning property of any panel. You can see the pure and pure jute, and after making of the PJVER, MHA PJVER biocomposite, that when we catch the fire, it is not not allowing to pass the oxygen on the surface. It arrests the surface by penetrating the oxygen molecules. Even though because these are the spherical spots are showing, or spherical images showing the nanoparticle which arrest the oxygen to not penetrating the fire. So here even after penetrating for 10%, there are the gases which is released on the surface, that is H2, hydrogen gas, as I said, CH4, CO, and CO2, and the smoke will release, oxygen also will be available on the surface. There is a char layer after burning. But in the deposition of MHA, the MHA protection layer on PJ or PJVER or MHA PJVER biocomposite is strongly protected on the surface. It cannot enter the oxygen to pass the heat or pass the heat waves on the surface. And after fire test also, you can see there are no fire on the surface. Only limiting amount of smoke will release or oxygen will release, and hydrogen also released from the surface. It means that our material is strongly protected on the surface of any kind of panel or any kind of fabric. It may be a jute, or it may be a silk, or it may be flax, or it may be cotton. And after char residues, after completely burning, we also tested the morphology of the material. So the char residues showing the PJVER, it is completely burned. But in the case of 1% char residue, it means the nanomaterial is not burned, and you can see on the surface very thin layer. And when the increase of the weight percent, it is a thick increase it from 1% to 2%. Thick layer you can observe, and more thick layer or a thicker layer you can find, or you can find up to 3% of char residue on the surface. It means the char residue is already there, even though we prolongedly heating, some area of the material will be charred, even though that part we took out and we checked the morphology, how the surface is protected with the MHA. Even though 1% to 3%, it shows very strong protection on the surface of the material. It means our material is commercially viable, and also it can be used for the society to stop the catch fire of ceilings or fabrics or whatever it may be. Also, we checked the chart with FTIR, XPS, Raman, and elemental analysis. We found different elements on the surface where calcium, oxygen, and oxygen in the different phases of 1s, calcium and 2s, and different phases of Ca2p. This is the orbital structure of XPS. And also FTR all showing CH2 groups and OH groups and phosphate groups. It means the phosphate group is appear means even after charring, even after prolonged heating, the phosphate is strongly protecting on the surface. This is the evidence of FTIR that peak is showing very clearly calcium and phosphate, and other CH2 groups and OH groups are appearing very clearly, and also the peak intensities are very high. It means that this is strong enough to protect the heat. Also, the elemental analysis showing the phosphate and calcium almost 4.72 from calcium. Phosphate is showing almost around 2, and carbon is 57.8%, oxygen is 35.2, and sulfur is 0.45. This is generating from the other materials. And also you can see the MHA jute char residue and XRD and what is that called, Raman. The Raman peaks are showing, the char is showing 1340 D peak, and 1596 is G peak. So these two signals are very important to find the char. So the XPS and Raman and FTIR strongly showing that our material is well enough to protect of the targeted fabric and targeted panel. Also, you can see this video before deposition, after deposition of flame retardant material. So the red one is without deposition, the white one is after deposition of flame retardant. So it is protecting very strongly. You can see the surface of the white and the surface of the brown. The brown is completely burning because we are giving the heat jet on the surface. It is catching the fire. But in this case, the left side, the white deposited a flame retardant material, the nanomaterial doesn't allow to catch the fire. So this is the real live video to understand our research. And I completed that project, and I also have some other important nano coatings for flame retardant applications. I can show you here. This is a microwave synthesized magnesium nanoparticles doped on jute fiber and reinforcement in biocomposites. This also very good output we got. So this is the nanoparticle of magnesium hydroxide from the magnesium nitrate we generated. So we dip the jute fibers on the surface of soaking in the inside of the solution, and we did microwave radiation, and we saw the depositions on the surface of magnesium nanoparticle. And after drying, you can see the magnesium depositions after checking by the FSM. You see the image, that image showing the foreign bodies on this each toe. There you can find the nanoparticle. And also compression molding we did, we make the panel as I told you, and as I show you VARTM method in the previous slides. And also this is another project, thermally exfoliated piper stacked blistered graphene oxide as efficient flame retardant soft nano bundle for vinyl ester resin composite. This is also we published in Material Advances, and the previous one we published in Composites B. So these are the top rated journals from Elsevier and Royal Society of Chemistry, London. Also, you can find here flame retardancy test we observed through these panels. And this is the VER polymer before depositing on the panels. And this is the BGO, blistered graphene oxide. This blistered graphene oxide is almost a thin layered material. This is a nano level uh, patches on the surface. Those patches we deposited on there. And also you can see the image. That image is, you can see like a paper-like mode that we can make into the thermal radiation at 500 degrees Celsius. We got the pop-up blistered graphene oxide you can find in this bottle. And this image having FSM, that is called B blistered graphene oxide. This graphene oxide is very expensive compared to the normal graphene oxide. Also, we studied insufficient fire retardancy property attained by multifunctional copper oxide, graphene oxide decorated on jute fiber mat. Also, you can see this copper oxide. These are the extendable graphite. Those graphites we deposited on the surface of jute. This is the combination we developed, and later we deposited and we checked the flame retardant test after deposition of the this copper oxide, graphene oxide on the surface of jute. You can see it looks like black, but at a different weight percent, the pure one is almost in brown because there is no deposition, and the weight percent is gradually increases from 1 to 3 weight percent. It shows the uh, morphology and image that shows it the black color. And when you start burning in the vertical burning test, the fire is not catching, even it is incandescent on the surface. The jet of the heat or flame is not catching the fire because the heat shielding coming from the this material. So mainly you also observe these two graphs showing that the heat release rate is very slow compared to the other or pure material after deposition of CuO graphene oxide. This is going to publish soon in the top rate journal. And also another one is synthesis of retroactive microcapsules having vinyl ester healing medicine for hybrid resin modified carbon fiber self-healing composites. This we can use for the aeroplane. And recently our central government has started Vande Bharat Express. Those cabinets are made of this kind of carbon fabrics. So these carbon fabrics are made with hybrid uh, carbon fabric material. This is called self-healing composites. Even though there is an accident on the surface, so it can be cured by our material. So it will be released immediately like a egg and yolk. The yolk will come out from the eggshell, and it will release, and the damage will be completely cured by the these nano capsules. These capsules are releases the curing material that will be deposited on surface, and you can see the depositions and you observe the composite fractures. So most of the aeroplanes are nowadays making with this kind of material because these are lightweight, and also they can save the energy and they can save the money, and also shelf life of the cruise, either it is a ship or Vande Bharat Express or bullet train or even it is air cruise. They can make with this kind of mechanical devices or mechanical material that can be helpful to stop the damages during times. So these are my research publications based on the flame retardancy, which are published during 2021 to 2023, and recent articles I am preparing to publish soon from Royal Society of Chemistry and Chemical Engineering Journal Advances, composites part B and material advances, and from other research areas like RS advances, nano energy 4, 3, 4, and composites, advanced functional materials 1 and 2. Also, I published in heat mass transfer and physica status solidi and nanotechnology for sustainable development, Journal of Material Chemistry, Angevante, JOC, Langmuir, tetrahedral asymmetry, etc. Of course, many are there, but I am showing some of them. And of course, this slide I have shown you previously, but I don't know whether I did or not. But again, I am refreshing this slide. So I met with Professor APJ Abdul Kalam during Indian Science Congress in 2001 January. We had a very good interaction, and I had a very good time. Almost 30 minutes I had talked to him, and he is the Professor Jiangwen Li from Georgia Tech. He is the editor of Nano Energy, and these are the people from Elsevier, editors, and he is the my co-researcher from KAIST. We published advanced functional materials together, and this professor is from France. He is also a very good collaborator with me, and he is the biomimetic nano actuator professor. We collaborated with the publication of biomimic sensory organization organs, and she is the professor from China. I forgot her name, but she is a very good collaborator with me. He is also from Tokyo Institute of Technology, and he is our Indian professor from New Zealand. He is a very good Bhattacharya. He is a very nice professor. He is also working since 30 years. He is going to retire in this year from Auckland University. He is a very good uh, scientist and professor to develop on natural fabric biocomposites. Thank you for your patience with my long lecture. If you have any question, I am ready to answer.
Yeah, thank you very much, Ravi. Now, Revati Vemuri garu raised their hand. Not only Revati Vemuri garu, can anyone ask any questions regarding these history of flame and fire retarding materials? Anybody may ask.
I hope
If
you
they,
understand my research because I have several areas to explain, but I cannot deliver in 1 hour all my research.
can anybody may ask any question? Professor Ravi Kumar Gar is available with us.
I expected a question from faculty.
Yeah. Actually, most of the 90% who are joined in this session are faculty. Very few are
Okay,
students.
thank you.
Yeah, Ravi, one question I am asking.
Sure.
Yeah, actually, you did a very good presentation regarding preparation of these fire retarding materials,
Mhm.
and by using bones and jute also.
Sure.
Can we set up this equipment at a cheap and best cost at our Indian conditions?
Why not?
In our,
Because research
how
labs
much?
everywhere is almost the same, but the instruments advancement is a little bit changes. We can do in our research departments. Sure. Of course, I can do because I have experience. Even though there are no facilities to ready, but still I can manage because with experience, with available tools, I do.
Yeah, because we experienced so many nano materials
Uh-huh.
regarding different applications. Yeah, first time I am listening about this flame or fire retardancy materials from your presentation.
Sure.
So that I
And
am asking.
IIT Delhi is working very large research on this area.
Okay, okay. Why you select these bones and jutes? Jute, any other material which is available in nature to prepare this material?
Bones are having phosphates.
Yeah,
So phosphates are strong enough to protect the heat.
yeah.
Even though you can straight away take the bone and on the burner flame, it cannot be catch the fire for even for a long time. It just make into the smoke, and it will be make a char layer on the surface. 100% it will not be burn out because of the phosphate bonding with the copper, sorry, calcium. That's why our teeth are very strong. The teeth also made with phosphate.
Yes, yes.
So because of that reason, I wanted to protect our valuable assets with this MHA. This is
Good.
of course get rid of material. That's why I used
Yeah. What about in case of jute?
jute.
In case of bone, we know about phosphate materials are existing in that.
Hmm.
What about in case of jute?
Jute.
Yeah.
Jute is made of cellulose material. That's why we
Oh,
protected.
yeah, yeah.
Why I took the jute? Because jute is used for industry applications for many areas.
Okay.
We can also deposit on the cotton, and also deposit on the silk, flax, and a combination of materials. You see, in my house, I'm showing this. This is the material coated with the nano material for the flame retardancy. So, so this is the door curtain from my house. So the advanced countries like Korea, USA, and UK, they are already preparing flame retardant curtains and door cloths and wall cloths, whatever it may be, to delay the fire catch immediately. So in the fourth slide, I shown you limiting oxygen index. That is, after coating and before coating of the cloth is 20 seconds. It is burned without coating. After deposition, it is almost increased to 20 minutes. 20 minutes means that is strong enough for escaping of our life and save our assets. Because many of the short circuits happening in the multi-story buildings, and when short circuit comes, the wall cloths immediately catch fire. So we cannot control it if you do not deposit this kind of flame retardant material. So this is a interesting technology. That's why I switched for partially. It's not full. It's not my full research. It's only
Yeah.
partial research.
Okay, Ravi Kumar garu, one is responding something. Any questions, sir? Ravi Kumar garu. He is an unmute. And Manjula garu, Konam Geri Manjula garu raised their hand. Any question, ma'am?
Sir, good afternoon. Good morning, sir.
Yes, yes, please.
Hello, sir.
Yes, madam.
Uh,
Yes, madam.
yes. Am I audible, sir?
Yes,
Yeah,
yes.
audible, ma'am.
Hello.
I am. I am.
Sir, very nice presentation. Sir, my question is that recently I studied that flame retardant material, that is cow dung also behaves like a flame retardant material.
Mhm.
That is fabrics coated with cow dung material. How can we prepare the nanomaterial? Can we prepare the nanomaterial from this powder itself?
Yes, madam. But the nanomaterial is made of original material. We decompose from the top to bottom. It means meter size to nanometer size. We make into decomposition, or we decay the material. And the surface area of the nanomaterial or nanoparticle is very high compared to the meter or millimeter materials. So even though you deposit on the jute or any fabric, you cannot see directly the nanoparticle. So the nanoparticle we can only see through magnification of FESM or TEM, transition electron microscope. That's why I shown the images where the particles are deposited. In the naked eye, you cannot see, but there is some lumps deposited on the surface. Those can be appeared by naked eye. Hope you understand.
Okay, sir. Okay, sir. Thank you, sir. But my question is that is powder material behaves like a flame retardant material, sir?
Yes, yes, madam.
Yes, sir.
That is I made from the bone only, animal bone.
Okay, okay. Thanks.
You can also make in your laboratory if you have it.
Now, Sharada Lakshmi garu raised their hand. Any question, ma'am?
Sir, my question is that is powder material behaves like a flame retardant material, sir?
Yes, yes. Yes, madam. 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 Yes, mad Anybody may ask question. Otherwise, you may type in chat box also. They will respond. If they may not ask question by using a microphone. Otherwise, you may chat box. Use chat box.
So this is my first international webinar on flame retardancy. I did not have experience earlier. This is the first time I gave outside my lab. So thank you, one and all.
Thank you very much.
Yeah. Anybody? Otherwise, we will conclude the program. Okay, thank you very much, Dr. Ravi Kumar, because your session is very, very fruitful and very helpful to the research people, not only the research people and faculty who are interested in research also. Because in our India also, most of the people belongs to physics and chemistry or nanomaterial research in different fields, of course. And this presentation is also helpful to the ongoing research people, and particularly on the synthesis and characterization of these nanomaterials by using bones and jutes, very cheapest material. And of course, these are waste material may be used for making these fire retardant material. Thank you very much for your presentation on behalf of Department of Physics and Electronics, SR and CVR Government Degree College. Thank you very much. Something, Ravi Kiran Garu, Elagapudi, raise your hand. Any questions?
Yes, sir. Good afternoon, sir.
Yes, good afternoon.
Your presentation is very nice and very informative, sir.
Thank you.
Sir, I just want to ask you one question regarding, can we use these materials for dielectric materials? Why? Because majorly in the dielectric materials, there will be many energy losses in the form of heat.
Yes.
So can we use these materials? Why? Because these are flame retardant. So can we use these materials in the dielectric materials to avoid the thermal breakdown? Because at very high temperatures, thermal breakdowns will be taking place and dielectric losses will be taking place.
You maybe use it, sir, but, because I have not studied about the dielectric characteristics of this material. But this is a highly brittle material.
Oh, yes, sir.
So that's why we need some kind of support polymer.
Okay.
If we have some support polymer, then we can make it.
So because generally the energy, most of the nowadays the energy storage devices are becoming into seen for the entire world. So if we can we use the can we make the dielectric materials using the nanomaterials as per your presentation?
Sure, you can use it. You can use it definitely, but certain percent. You cannot use 100%.
Okay.
So in my case, I used only 3 weight%. Means 100 grams of jute, I used only 3 grams of MHA. Okay. Maximum.
Okay, sir. Thank you.
Yeah, because there is a chemical bond on the surface of jute as well as phosphate.
Yes, sir. At the high temperatures, majorly the covalent bonds they will be breaking up. So as the number of bonds are breaking,
that's why I mentioned very clearly ion electrolytic bonds.
Okay. Only electrolytic bonds.
Yes, it means ionic bond.
Okay. Thank you, sir.
Yes.
Thank you very much.
You're welcome.
Yeah. Anybody? Yeah. Thank you very much. Thank you very much.
I will give you oral lecture in your department.
Yeah. Thank you. We'll wait once when you came to India.
Okay.
In our department also. Thank you very much for your presentation and giving time to us, even though you are so busy in your works. Thank you very much. And
Yeah, I
dear
thank
friends,
you,
actually,
all your department people, and also to your college and your correspondent, even principal, whoever may be, for giving me a great opportunity to share my knowledge.
Excellent.
thank you, thank you. A small break for 5 minutes. Thereafter, still in line. After 5 minutes, we will continue the second session by very eminent professor, Dr. D. Pamugaru, from Indian Institute of Technology, Guwahati.
Okay, bye, all
Thank
of
you,
you.
thank you, thank you.
Yeah.
Sir, good morning, sir. Dr. Pramu, sir. Now I request Dr. A. Ashwaradan Garu, organizing secretary of this webinar, will introduce our today's second resource person, Professor D. Pamu, sir.
Thank you, sir. Good morning, everyone. A warm and heartfelt welcome to all. I take this opportunity to introduce Professor Pamu, sir. Dr. Pamu, sir, is a professor at the Center for Nanotechnology, Indian Institute of Guwahati, Assam, India. We are very much delighted to say that Professor Pamu is a pearl of Government Degree College. Sir completed his graduation from Silver Jubilee Government Degree College, Karnool. Sir pursued his MSc, MPhil, and PhD courses from University of Hyderabad. Sir is a gold medalist from the University of Hyderabad during his masters. Sir also had a postdoctoral position at the University of Hyderabad. It is impossible to mention Sir's each and every single accomplishment because they are numerous in number. I would like to mention few feathers that made his crown. Sir's work has recognized by Indian Space Organization for his contribution to make ZST MIC substrates suited for space applications. Sir optimized the processing variables to prepare the ceramic disc, sputtering targets indigenously and transfer the technology to the industry. Sir's work have been recognized by many different bodies like Science and Engineering Research Board, Board of Research in Nuclear Sciences. He was the recipient of Young Scientist Research Award twice. Sir's research focuses mainly on high K and low loss materials, microwave ceramics, ferroelectrics and piezoelectrics, bioceramics, microwave ferrites, oxide thin films, nanomaterials, and semiconductors. To his credit, SAR has organized several national and international conferences, workshops, and QIPs. 12 students have completed their PhD under his able guidance, and 12 are in pipeline. SAR had patents and several funded projects to his credit. SAR is an invited speaker at 87 international conferences held in India, China, Taiwan, and Australia. Sir also had several publications and around 176 with good citations and also had book chapters. Thank you so much, sir, for readily accepting our invitation to deliver a guest lecture. You have taken time out of your busy schedule to make your presence felt. Thank you for doing so much for us. With this brief introduction, I welcome Professor Pamu, sir. Sir, please.
Yeah, thank you for the warm introduction. Could you please share the screen? Then we'll continue with the presentation.
Sir, is it visible to you?
Yeah. So good. Thank you. So just a second. I'll yeah, maybe turn into full screen from my thing. Yeah. So very good morning to all, and thank the organizers for having me. So today I will briefly talk about what we are doing in our institute. Actually, this is not my work, my students' work. Has been told 12 students' work. I go here and there and present. They are the ones who work for me, and I tend to present. And I thank all my students. This is one of the students' work I am presenting. Her name is Pallavi Gogai, and she is an assistant professor in one of the degree colleges in Assam. So when it comes to the work, I'm just trying to put up, very little portion of the work we have done. But I would like to, I would like you people to ask me more questions, with respect to some other opportunities, all that. I'll be very happy. So as has been shared, we are working on many other materials, biomaterials, and then microwave ferrites, all other materials. But this is a special class of material that is being we have developed to ISRO. This project is sponsored by both ISRO and IPR, Institute for Plasma Research, under this material is being developed for microwave window applications. So I'll come to you. So today our focus is on nanotechnology. So now I would like to bring two ways of nanotechnology to your presence, and we may discuss some of them. So when we talk about nanotechnology, there are many ways we can make nanomaterials. So in my present talk, so as I told you, I will just briefly give you a small introduction to both bulk and thin films, and then we, we start with the nanomaterials. Nanomaterials, many times we think we can only use in the nano, but in this study, first part of the study, we have prepared the nanomaterials and took the advantage of nanotechnology to make a bulk material. How we have done that I will discuss. And second part is that we have deposited a thin films of the particular composition that we have shown here, magnesium zirconium titanate. This is the material that we have chosen for our study. Why we have substituted magnesium, zirconium in the titanium site is to, to induce or reduce the lattice distortion, so that the system will be in the more ordered state. That leads to a good microwave response. That is the idea we have behind this thing. Can we go to next slide, please? Yeah. So when we talk about mostly microwave applications, now we are talking about now all the applications related to gigahertz, and future we are trying to go with the terahertz. That means as you go higher and higher frequency, you know that the wavelength is decreasing. So why now if we talk about any material, as we go higher and higher frequency, uh, because higher the frequency, you will have a very fast response. If you want to have that, you have to have a material which is capable of responding and storing the entire electromagnetic radiation in that material. Otherwise the entire device is lost. Why it is lost, I will tell you as we go on. So the material that we have told, as I told you, we prepared a nanoparticles. That nanoparticles we use to get a good bulk response of it. How did we get for space applications? I will tell you here. Before that, let me introduce the physics concept of it. This is the +2 physics or maths by BSc concept, and how, even though the concept is very simple, but how do we make use of that for the device application is the challenge. That's what we are going to do. So these materials we call them as a dielectric resonator. What is a dielectric resonator? It is a ceramic material that is unmetallized object. When you feed the electromagnetic radiation to this unmetallized object, what happens? You will have a it will function as a resonant device by means of a reflections at the high dielectric interface and the air. How that is done? Can you put one more enter? Here. So why these dielectric resonators are important? Why we now we are talking about these resonators? This is not very new technology. It is old technology. Earlier people used to use the cavity resonators, micro strip line resonators, and then came the dielectric resonators. What is the advantage of dielectric resonators compared to cavity and micro strip line resonators? They are very bulky, and because when you send any device for space or any miniaturization, you have to have a very small device possible. That is the advantage of the dielectric resonator. So can you put one more enter? Yeah. So if I want to use any material for microwave application, what should I do? What are the properties? Can I use any material for microwave application, or any particular response is required? So if you want to use any material for microwave applications, these three are important parameters. That is a high dielectric constant, epsilon r. Means what? There is a expression, there are many other parameters. If d is your device size, your d is inversely proportional to the square root of epsilon r. What is the meaning of it? That means if you want to have a smaller device, you need to have a larger dielectric constant. You may say that, sir, there are many materials which can give thousands of dielectric constants. But why you are talking that? There are many material which can give thousands of dielectric constant, but the problem is there are other parameters we need to look at, and that too, this dielectric constant we are talking at a microwave frequencies. So that is the reason, if I need to have a good dielectric constant which will help me to facilitate the miniaturization. And then high quality factor. High quality factor means what? It will have the sharpness of the signal. If some of you, if you are above 30 and all, if you had bought your mobile maybe around 2008 or 2009, what used to happen is that whenever we want to call someone, we used to listen somebody's voice conversation. We used to call someone, but our phone is merged with somebody else, and we used to listen their discussion. What is the reason? What was the problem? Because the sharpness of the signal is poor there, and also the noise is more. That's where it used to intermix. That's where now that problems got solved. That's where you have a very good signal quality at the microwave frequencies. And the temperature stability. What is the temperature stability? What is the importance of it? Suppose I fabricated a device at the Vijayawada, which is the temperature is about now 38 degrees C. If the same device I tested here, everything is working fine. When I send it to space and the temperature is much lower, then the resonant frequency, because these are all resonant devices, the resonant frequency should not shift. Suppose I designed my communication device at a 8.9 gigahertz. So when I send this same device to the space, the resonant frequency, if it is drifts, 8.9 gigahertz becomes 11 gigahertz or 7 gigahertz, then I will not be able to communicate with the device. That's where the low TOF is that temperature coefficient of resonant frequency. It should not drift much. So these are the three important parameters if I want to use any device for a communication application. So this is the background of this, and we will move on. Can you go to next slide, please? Yeah. So what is the funda in this? If you understood this slide, you understood this entire lecture, or what is all about space communication and the importance of material science, you will understand. So what is the significance is that, Lord Rayleigh told, if you take an infinite to long dielectric material and you feed the electromagnetic radiation at a particular angle, what happens? The entire electromagnetic radiation is internally reflected. What is the meaning of it? That means when you feed the signal at a particular angle to a dielectric material, then the entire dielectric constant or the entire electromagnetic radiation is stored in that device. That is where you will have a very good quality of the signal, and you see that is again related to your dielectric constant. Okay, so that is how the dielectric materials are being used to store the electromagnetic radiation. So can you go to the next slide, please? Yeah. So if you look at these devices, and one beauty of these ceramics is that once you prepare a material with the required properties that we have discussed in the second slide or third slide, you are done with the device, because you straight away keep your device in the part. You see that in the slide it is shown now, dielectric resonators are there, you see. straight away. You don't have to do anything, just a simple polishing, and straight away put it in your antenna. You can put it in a filter, you can put it in a oscillator, everything. It is the simplest thing. Just you just have to prepare the material with the required properties. If you are done that, then you are ready to, you know, operate the device. That is the beauty of dielectric materials. Can you go to the next slide, please? Yeah. So there are different types of shapes are required depending on your application. So you can make all these varieties of things, and you say that any communication you name, whether it is a radar, cordless phones, so GPS, everywhere. Without a dielectric resonator, even your mobile will not function. So that is the importance of these dielectric materials in the communication device. Can you go to the next slide? Yeah. So as I told you, why did we choose this material? This is this material seems to be very simple. Just magnesium oxide you take and titanium oxide you take and mix it. You should get a in principle magnesium titanate. But it is not a simple material because it is a hygroscopic material. Because the moment it reacts, it sees some kind of moisture, it immediately forms. There is a secondary phase called Mgti2O5 as a secondary phase. So as a result, this material, even though it seems to be simple, but it is not very easy to process. That is where we took this material as a challenge to propose for a space application. Can you go to the next slide, please? Yeah. See, anything, most of you, when I heard some of you are doing PhD and some of you want to do PhD, some of you have completed PhD, but you need to publish papers, all that. Whenever you look at any problem, the first thing that you need to look at is the novelty. See, these are the already best papers published based on this material. You can see that the material centering temperature is crossing, it is above 1400, and it is not very easy to prepare this material. So now what is the specialty of ours? This is what is the same question is asked by ISRO people also. Already people have done this work. What are you going to do? This is what is the challenge. But if you look at the centering temperature is above 1400 degrees C, which is very difficult. But there is another technology called LTCC, low temperature co-fired ceramics. Low temperature co-fired ceramics means you will have a ceramic and then low melting point metal. For example, silver. Silver melting point is about 960 degrees C. So if I have a silver with the material, then and it is need to be fired. Co-fired means metal and the ceramic we will fire together. That's where we call them a low temperature co-fired ceramics. You have a high temperature co-fired ceramics also. What we do in the case of a high temperature co-fired ceramics, we will use a noble metals, gold, platinum, like that, because they go higher temperature. If you do a material technology at low LTCC, it is more efficient. So this is what is our challenge. So now if you look at here, 1400 degrees C is the temperature. Now what we proposed is that if we can reduce the processing temperature without compromising your dielectric constant and quality factor, your left hand side, left hand side two columns. If we can do that without compromising the dielectric constant and the lost quality factor, and reduce the processing temperature, that is the challenge that we have taken in this study. Can you go to the next slide, please? Yeah. So as I already told you about the motivation behind choosing this material. So you can skip this slide. You can go to next slide. Yeah. Yeah. So this material we have prepared using a method called the polyol method. So this, if you type this composition in the Google, you will have a one paper named by Pallavi Gogai in the Journal of American Ceramic Society. If you want to see more details about it, you can see. This is the processing steps that we have followed. Why did we choose a polyol method? In the previous slide, we have seen they are all using a solid state reaction method. When we use a solid state reaction method, material will go into a bulk state. That's what we don't want to go with a bulk state. If we go, there is no advantage to reduce the temperature. That's where we started with a low temperature processing method, which is called the polyol method. We slightly modified this method and did this work. Can you go to the next slide, please? Yeah. So whenever we start, process a material, immediately what we need to do is that, because temperature is a crucial factor for us, what did we do is that we want to find out at what temperature this material crystallizes. So you see that around 500 degrees C, this material is crystallizing from DSC TGA, and using that we have calcined this material to see the phase formation. Can you enter? Yeah. So when you do that, you see that we have calcined the material at a different temperatures. Here you see that based on the above thing, when we calcined at 500 degrees C, there is no phase formation. When we see 550, there is a phase formation. When we do 600, we did a good phase formation. Even 650, good phase formation. So it is good when we did with the XRD, but sometimes problem with the XRD is that you will not find if there are impurities present in the sample. That's where what did we do? We have taken a Raman spectra, because Raman is a very sensitive tool, to look at the impurities. So that's where we have seen, and we found that Raman also is not giving us any secondary phases. So that's where from this, to be in the safer side, we have chosen a calcination temperature around 600 degrees C. Can you enter to the next slide, please? Yeah. So how did we say that we have gotten the good nanoparticles here? So you see that the TEM images we have shown here, which are calcined at 600 degrees C, and you see that the beautiful, you know, microstructure we can see, which are of small particles, and which is about 30 to 40 nanometers particle size. And then we have also confirmed the phase purity by looking at the SAD pattern. You see that you see a bright spots, which will tell us the crystallinity of the material, and crystal planes also we could able to confirm. So what did we do? We started with a low temperature process. So at 600 degrees itself, we are able to get the phase of the material. Now we need to go for further processing of the material. Can you enter the next slide, please? See, and we have also calculated the band gap. Generally, the reported band gap for this material is about 3.5 electron volts. But here you see that the band gap is increasing. Why? What is the reason? When you look at when you go to the nanoparticles, there is a quantum confinement that is coming into the picture because of the small particle size. So as a result, what happened? The quantum confinement, the band gap is increasing. This is the reason for the increase in the band gap. Can you go to the next slide, please? That's okay. You go to the next slide. And then what we have done is that we have sintered this material. Now we have only got the phase, required phase for the uh, material, but we need to compact them. That means if I want to say dielectric resonator, it is like your paracetamol tablet. So even if I drop, 10 meters above to the floor, the material should not break. For that, what we need to do? We need to induce the density in the material. If you want to induce the material density, what you need to do? You have to make a disc and fire it at a higher temperature. So that's what I have shown you in the literature review, that these people have centered at a 1400 degrees and all. So now, since we have started with smaller particles, as I shown you in the previous slides, so about 30 to 40 nanometers. So now we started centering at 1000 degrees C, 950 degrees C, 900 degrees C, 850 degrees C, to see the density of the material is coming or not. So we have seen that the density of the material is nicely, coming up, and there is no secondary phase even after densification. And the right hand side is the figure of the XRD pattern. We have refined it with Ritwil refined it in order to find out if there is any phase or not, secondary phase or not. We found that there is no secondary phase, it is a pure phase. And what we have seen is that we have gotten a very good phase at a 950 degree, or in all the cases it is there. But what is the effect of density, we will see. Can you go to the next slide, please? Hello. Yeah.
Yes, sir.
So now, if you see now, The microstructures, when I say density is good, what is the meaning of it? The compaction of the materials will be very high. That means density is higher means lesser the porosity. You see that the material density is very high. So we have centered at, as I shown you, 850, 900, 950 and 1000 degrees C. The sample centered at 950, you see a very good uniform microstructure, and there are no pores at all, well compacted material. Yeah, where is the density coming from, and what is the use of nanotechnology is here. What did we do is, when we started with the smaller particles, when you fire it at a 900 or 950 degrees C, you see that the compactness of the material is increasing. What is the reason? Because when you use the nanoparticles, the surface to volume ratio is so high, the densification or the centering velocity is very high. This centering velocity will help the material to get compacted nicely. That is the reason you have a very good microstructure that is possible at a low temperature. As I shown you in the literature review, what is the difference in our work and reported work? Here, what did we do? Literature is looking at a 1400 degrees C and above. We are able to do a 950 degrees C with a good compaction possible. What did we do? We exploited the nanotechnology in order to get a material which is highly densified and suitable for a space application. That is the task that we have done. Can you go to the next slide, please? So now, how did you say that, sir, the material, what is done in the literature review and your material, what is the goodness of it? Now you see that the relative density we have shown you, centered at 850, 900, 950, 1000 degrees C. 950 degrees C, you see that we got the density about a 97.5%, which is a very good density with an average grain size about 3.3 microns. And you look at the dielectric constant. This dielectric constant is measured at around 9 gigahertz, 9.5 gigahertz. You see in the green letters it is given. These microwave measurements are also very tricky, which I don't want to go now into the details. If anybody is interested, we can discuss. This we see that we measured the properties at 9.5 gigahertz, and you see that we got a excellent dielectric constant about 18. And the quality factor, you see that what is reported in the literature and see. In the literature, it is reported in the gigahertz range. We got a very good response about 175 terahertz. That means, how did you get terahertz? You can ask, because when you multiply the Q, the quality factor, and into the resonant frequency, that is 9.5 gigahertz. If you multiply, this is the number you got. This is the best number ever reported for this material, and that's where we are successful. Now you see that the material which is people are reporting at 1400 and above, at 950 degrees C itself, we got all the good properties that are required for application, especially in the in view of LTCC. Okay, can you go to the next slide, please? Yeah. So why did we do this measurement is that, these are done at low frequencies. These are all, in order to do these measurements, we need to have a parallel plate capacitor. That means you make a thin ceramic disc or pellet, and then both the sides you apply silver paint, and then do the measurement. When you do that, here the dielectric constant seems to be very high, because it will be naturally, because your electrode contribution is there, and this is at a low frequency. Just to, for curious, yeah, so that is where the dielectric constant seems to be higher, and the loss tangent also seems to be higher here. Why? Because the silver electrodes also will contribute, because to temperature, silver will, there is a little bit of porosity, into that it will diffuse, and it will also try to enhance the loss factor at a lower frequencies. But when we do microwave measurements, you don't have to apply the silver paint there. It is a polished ceramic disc straight away. Okay, that is resonant method. This is a parallel plate capacitor method. Okay, can you go to the next slide, please? Yeah. So this is an impedance spectroscopy. Why did we do an impedance spectroscopy? Is that, see, when you look at the microstructure of the material, you have seen a nice grains possible. We want to figure out what is the contribution from the grain and the grain boundary. If you have a more grain boundary, then your material will be very lossy. But if you have a very good grains, you will have a best material response. So in order to find out that, we have done this thing, and we see that why there is a loss increasing at higher frequency is because higher temperature, because there is a conduction that is getting increased in this case of material. Can you go to the next slide, please? Yeah, and also we see that we want to look at what is the activation energy. So we want to see the activation energy. Why do we want to do a activation energy? What is the purpose of doing activation energy? Because this is a self check test. What is the meaning? You may say that, sir, you are saying 97.5% density. And what is the surety? What is the guarantee? So you see here, when you do that, here the activation energy is a very high. What it will indicate? The when you have a higher activation energy means you will have a very good insulating nature of the material, and also it will reflect the conductivity of the material, which is a very smaller. We want to see why we are doing this AC conductivity, all that, because we want to see how stable is this material, because that is the reason we do all these measurements. Can you go to the next slide, please? Yeah, so this is what we have done in terms of bulk. So what I have shown you in the literature and what we have done, this is a good accomplishment. What we have done is that we have taken an advantage of nanomaterial, and we try to get the response which is required for a space application, at the same time reducing the temperature. So that is the beauty of using the nanotechnology for the space application. This is the summary, and we will go into the thin film. Can you go to the next slide, please? Yeah, so next slide. See, and why are we doing these thin films? Because now you may say that, sir, this workshop is all about nanotechnology. You took a nanotechnology and made it a microtechnology. What about nanotechnology, pure nanotechnology? So what we did is that we made a ceramic target of the same material using the conditions that are mentioned here. Can you go to the next slide? And what we have done is that we have made a thin films of it. What is the thin film? Thin film is nothing but a three-dimensional structure where your thickness is much less than the other, compared to the other two dimensions. So that is your length and width. So what is the beauty of thin film technology? In the thin film technology, purely when you deposit thin films, whatever, see, in the previous case, the material that we used for space application is as big as your paracetamol tablet. But we want to see, suppose if I make a 200 nanometers, that means 1/5 of thickness of your hair. Your thickness of your hair is about a micron, but we are making a thin film which is 1/5 of it, about a 200 nanometers. And when we make a 200 nanometer thin film, how does it behave? We want to see the material that we have prepared in the bulk form, and when I made it as a 200 nanometers thin film form, how does it is behaving? That is what we want to see. Using to do that, we made a target, and these are the deposition conditions, with the vacuum technology, all that. And why I am putting up is that nowadays the government of India is setting up the semiconductor fab labs, and this is a great use for MSc physics students, where people learn about vacuum technology. You will have a lot of scope about semiconductors. You only study better material science and you understand vacuum technology, you will be having a lot of scope. Because last Friday we were in Delhi. We were government is asking to train the manpower, and in India there is no trained manpower for that. Immediately to start these 3 semiconductor fab labs, they need a 70,000 manpower, trained manpower. But in India there is no one. In fact, we have to train even ITI students to maintain certain things. It is so mechanical. Everybody is required, and especially you people should read about thin film technology, vacuum science, what is all about, and there is a great requirement for this industry trained manpower. Okay, can you go to the next slide? Yeah, so what did we do is now we want to do a bulk from bulk to thin film we want to do. So this is the target material we have just make sure that because this is a 2-inch disc, we when we make such a big disc there may be a possibility of impurities. To make sure that there are no impurities, we tested the disc of a 2-inch. Can you enter? Yeah. So now what did we do is that we made a thin films on silicon, platinized silicon substrate and quartz substrate. Why do you may ask why what is the importance of a platinized silicon? Because we want to make a thin film capacitor. When I make a thin film capacitor, what is required? I need a bottom electrode and in between my magnesium titanate thin film and top electrode. So that's where to keep inherently bottom electrode we chose a platinum. And why did we choose a quartz substrate? Because we want to do a in order to do optical properties we need to have a transparent substrate. That's where we have chosen a quartz. So here you see what did we do here. The beauty of thin film is you can fine tune the properties with when you vary the processing parameters. What did we do here? Since it is an oxide material, so we played with the oxygen and argon composition. You may ask, sir, where is the oxygen? Where is why oxygen is coming and argon is coming? When you say sputtering, what is sputtering? You take a 2 electrodes, positive electrode and negative electrode, and you apply the potential between these 2 electrodes. And when you apply the potential, then you pass the inert gas, argon. What happens? This when you send the argon gas between 2 electrodes, your argon will get ionized. That is, your argon will become Ar plus 2 electron minus. So this Ar plus, if it is your target, the ceramic disc, we keep it at a negative potential. So this Ar plus will go and give its energy momentum, its momentum to ceramic target and dislodge the magnesium titanate atoms. That is what is called the sputtering. So that's where argon is required and oxygen. Why are you putting oxygen? Because this is an oxide material. When we process the material at 950 degrees C or higher temperature, what happens? There may be a deficiency of oxygen. That is the reason we introduced oxygen into the chamber. And you see that there is a nice, crystallinity of the films. And these are all just 200 nanometer thin films. Can you go to the next slide, please? Yeah, so here what is happening is that in thin film, what is the beauty is that you can orient the direction of a thin film, like you have a different lattice planes, right? 1110, 111, or 100, or 101, different planes. Because in the previous slide we have seen certain peaks are increasing. That means orientation is increasing. In some cases, it is decreasing with respect to the oxygen percentage. That's where OMP is the oxygen mixing percentage. Next slide, please. Yeah. So how do we say that we have gotten a nano thin films here? You see that the films left hand side, these are all as deposited, and right hand side are annealed. So you see that when you deposit these films, they are nicely, uh, nano beautifully arranged. See that 200 nanometer thin film, when we anneal on the quartz substrate or SiO2 substrate, you see that how nicely, beautifully the nanoparticles are aligned. And why did we anneal? Because we want to have a good crystalline material, because good crystalline material only will exhibit a good response. That is the reason. Next slide, please. You see that with respect to different oxygen partial pressures, we have shown you the micro AFM pictures. AFM is nothing but atomic force microscopy pictures, where you will be able to see at a nano level the beauty of arrangement of grains that are present in the sample. You see that the samples are purely in the nano scale, and they have a very good response. So can you go to the next slide, please? Yeah. So why, then why did we, as I told you, why did I use SiO2 substrates? Because to look at the optical properties. You may say that, sir, how do you say that there are this material is a thin film is a 200 nanometers? You see that left hand side, there are nice fringes, interference fringes are there. From these fringes, using below the formulas here given, from these fringes, we will be able to figure out what is the thickness of the material, what is the refractive index of the material, what is the band gap of the material. So these are the expressions given here. You see that this, when you deposit these thin films, it's beautiful that almost 99% of the light will transmit through. What is the advantage nowadays? You look at buildings, Microsoft or Google, when they make the buildings, they make with the glasses. Why do they make with the glasses? Because on the glass, if you deposit this material, what is the beauty is that it will absorb UV radiation. Now in summer it is damn hot here, there will be UV rays coming, and they are harmful to our body. So if you can coat this material onto the glass, there is no light you are losing, because 99% of the light is transmitting through the magnesium titanate material, and it will absorb the UV radiation, and it will reduce the heat portion inside the room also. That is the beauty of this coating. And can we go to the next slide, please? Yeah, so here we have calculated the refractive index, all that which is required, and we correlated with the other properties, packing, porosity. What is the porosity in the material? This is an optical porosity, please remember that. Next slide, please. Yeah, so you look at now, when we did the dielectric properties at lower frequencies, in the case of bulk material, now the dielectric properties at with the thin films at the lower frequency, you look at both the properties are similar. In that case, when we made a disc, there we need 1 gram of powder to make a disc of a 10 mm diameter and 1 mm thickness. But in the case of thin film, it is the 200 nanometer, which is a very less. You can look at what is the in 1 mm thickness and 200 nanometer difference. What is the thickness? And interestingly, both the materials showing the same response. What is the beauty here? This is what is the nanotechnology here. Beauty of nanotechnology, where you are bringing the surface effects into the picture. That's where, due to the large surface to volume ratio, even the bulk material of 1 gram powder, whatever response it is giving, the thin film of a 200 nanometer itself is giving a similar response. That is where the nanotechnology, in the case of nanotechnology, the device size is much smaller. That is what is happening. Can you go to the next slide, please? Yeah, here also we want to look at, compared to the bulk, here the resistance is the lower. When we look at the impedance spectroscopy, why? Because in the case of bulk material, in the previous section when I showed you, the grain size is about 3.3 microns, but here the grain size is about 30 to 40 nanometers, and that's where you see that the grain boundary response is increasing here. That is one thing that we need to note in the present case. Yeah, next slide, please. Yeah, so here also you see that the relaxation time is there, and from this also we see that in this case the activation energy is less, because these are thin films which are about only 200 nanometer. In that's where the activation energy in this case is the smaller, but in the previous case the activation energy is much higher. Why? Because you are having a bulk material that is possible there. Next slide, please. Yeah, that's where we want to see, when we plot, these are all called the Cole plots, where you plot Z prime versus Z double prime. And when we look at what is the significance of this, you see that there is a resistor and the capacitor. The resistor indicates the loss of the material, capacitor indicates the storage of the material. So from this we will be able to see that both the grain and grain boundary contributions, and which will tells us. Then from this, using the RC combination, we will be able to now electrically and electronically, we will be able to understand the device stability much better. That is the significance of this study. Can you go to the next slide, please? Yeah. So and here, this is the summary slide, and afterwards I will introduce you one program, and then we can have a time for questions. So you see that this student has done a different combinations with the bulk material and the thin film material. You look at the dielectric constant of the material, more or less is coming out to the same. Bulk material, the dielectric constant is coming 17, but in the case of thin film, it is 11 and 15. So more or less, it is of that order, because in the case of bulk, if you want to make a dielectric resonator, you need more than 3 grams of powder. Don't get confused when I say that 1 gram for parallel plate capacitor parallel plate capacitor. If I want to make a paracetamol kind of tablet, which is called the dielectric resonator, and that is the comparison we are doing here. There we need a 3 grams of powder, but here thin film is a 200 nanometers of the powder. 200 from that disk we are able to take only 200 nanometers out of it, and the more or less the bulk properties and thin films are comparable. This is where the nanotechnology comes into the picture, and this is the beauty, when we use the nanotechnology to simplify simplify the device structure, at the same time improve the performance of the device. This is the summary that you can look at. Can you go to the next slide, please? Enter, please. Yeah. Next. Yeah. This is the summary. It's not. Go to the next slide. These are some references. Next slide. Next slide. Yeah. So these are the some of the devices that we made that are useful for both semiconductor industry, and some of the devices we have given it to the ISRO space. So from that, we have just started, selling these products. In India, nobody makes this kind of device, the discs for fabrication of thin films. So we have found a company, and these are the some of the devices that we made, and these are all required in order to make a nano devices in the semiconductor fab lab, and we are the manufacturers for that. And I think we are done. And before that, if anybody, before I conclude, if anybody is interested to do a more work, to develop sensors, to develop, you want to do a energy storage devices or solar cells, all that, there is a program called INUP. INUP is meant is nothing but a Indian Nano Electronics Users Program. INUP I2I, in idea to innovate electronics. This program is sponsored by Ministry of Electronics, MIT, and IIT Guwahati is the nodal institute. Not only IIT Guwahati, IISc Bangalore, IIT Madras, IIT Kharagpur, IIT Delhi, and in partnering with IIT Bombay, we all together we run this program. Every year. The first phase is ending. So in the next phase, maybe it will be coming, where we will conduct online lectures, in online, and after the workshop is done, we will conduct a quiz. If you qualify in that quiz, we will call you to IIT Guwahati or any other institute. They will call you to their institute and do an offline workshop. That means whatever has been taught in the online, they will take to the slightly further workshop. That is called the offline workshop. Then if you are doing well in that offline workshop, then we will call you for a hands-on training. What is a hands-on training? This is about 2 weeks. What is hands-on training? We will teach you how to operate a sputtering system, how to fabricate a solar cell, how to fabricate a LED, how to fabricate a SAW device. These devices we will make you to do in that 14 days workshop, where we will only give you a guidance. You yourself will operate the equipment and make the devices. Then we will ask you to write a proposal. If you, based on your experience and what is the area you want to do, if you write a proposal and whatever is required for that to execute that proposal in terms of chemicals, in terms of substrates, any other infrastructure required, all that we provide for you at a respective places where you can come and do your work, and you don't have to even give us the othership. It is you, it is your idea. We will only give you the facilities, and you can do the device or whatever work you want to do and publish. And that is the idea of this program. So you can make use of this program because we will give you all the facilities possible, because we have given for some students we bought even a gold, platinum, which is consumables. Each student we spent about 7 to 8 lakhs of rupees of consumables and high quality equipments. Everything we will provide at free of cost. On top of it, your travel, your food, your accommodation, everything is paid by the particular IIT. So this is the best program you can utilize. Maybe next time when the next phase starts, maybe I will try to inform you people in the group, whoever is there. Maybe you can make use of it. So with this, I will conclude here, and if you have any question to ask, I am open to take your questions. Thank you.
So thank you very much, sir. Very nice presentation regarding thin film technology. Now it is open to all queries. Please, anybody who are participating in this program may ask any questions, sir.
Yeah,
If
please.
not, you are not able to ask a question directly, you may post your query on the chat box also.
Hello.
Yeah,
Yeah,
okay, sir.
please
Ravi
go
Kumar
ahead.
Garu, please. Yeah.
Yeah. Thank you, sir. Thank you for your wonderful lecture. I have few doubts actually. Microwave digestion. We use the samples like food sample or pharma samples or cosmetic samples to break down the material for elemental analysis. Okay. So is it useful to, like, we use the higher temperature there also microwave digestion? So is it we can use this application in that the instrument or microwave digestion to make, because we have to wait for 2 hours to break down the sample. So instead of that waiting 2 hours, we can reduce the time also. That is my question is to we can use the same technology for that instrument to minimize the sample digestion time.
This is not very
Or
straightforward, as you said, because this is a food material you are saying, right?
not only food, like pharma, food, and cosmetics, to break down the, because it's complex materials, right? These materials.
Correct.
So to analyze, to break down the materials as the metals or food or separate, to simplify
Okay. Yeah.
from the complex to simply simplify. Like for example,
You
if I
want to
want to
refine
analyze
it and
heavy
separate it.
metals,
Yes.
yes,
Yeah. This is
Then-
not what we have discussed is not a correct viable method, but
yeah, no, just
yeah.
it's like not direct actually. I'm just asking, is there any application or in future you are going to work or something like?
Yeah, actually, we put our finger in many areas, but one of the areas is this. We do that actually. We do that. Many people are approaching, but the problem is we are limited with our resources. In the sense, we are occupied with too many projects and the students and the teaching load. But I think
Okay.
if time permits, we will be interested. Because this is an important area we can develop, especially in India. This market is very poor, which we
Right.
need to take up. Yes.
Okay, sir.
Yeah.
Thank you.
Thank you.
Can anybody? Dr. Pamu, sir, actually you asked about the workshop on hands-on training for fabrication of LEDs you introduced. Actually, what is the time we can apply, and to whom we can apply, and what are
Actually,
the
see,
minimum requirements?
there is now the last 3 years we have done. First phase is done. Initially, the government of India has given us 3 years of time, which we have started in 2021 September.
Yes, sir.
So now this is 24 September. This program is going to end,
Okay,
and maybe it will start again. 24 like 25 middle it will start because the next phase government has to sanction. The first phase is done. There were many people from Andhra have come there, many engineering college lecturers and degree college lecturers, and some of them who have registered for PhD, they came and did the program. And if we get a good response from your institute,
Yeah.
we can even make MOU with you.
Okay, sir. Okay.
If we make MOU, you not only during the workshop time, later anytime you are freely, you can freely come and use all the facilities.
So,
So that is the
utilization of
advantage.
this only at your institution, sir? Or can we make at my institution also?
Anywhere. But IIT, we conduct, we are the nodal institute. We do all the institutes coordination and all. But there is a website called INUP, INUP-I2I. It is if you type in Google, you will have that. All the notifications will be there in that website. As I told you, all the 6 institutes, 5 IITs and ISC Bangalore. And in the next phase, even IIT Hyderabad, they are going to consider. So you can even visit IIT Hyderabad or IIT Chennai if you wish to. So not only Guwahati, anywhere you can do that. And all the institutes will have the similar procedure to adopt.
Yeah.
So you wait for, if at all in early terms it comes, because now we are doing, last week only we did the offline workshop and hands-on training we are doing, but we cannot call you people directly to hands-on training. You have to attend the online workshop, then offline workshop, and then hands-on. So now you don't have much option, but if there is any option, I will post you people.
Yeah.
But if you want to have a regular updates, you can just look at this website, inup.i2i, inup dot, dash i2i.
Yeah.
If you type in Google, you will have a website where all the 5 IITs and ISC Bangalore, what they are doing, how many people have attended, including their names. Sometimes you will be able to see.
Yes. Thank you, sir. Thank you. Anybody, please respond. Any queries? Any doubts? There is no queries. We will close this session.
Thank you.
Sir, thank you very much, sir. Even though you are so busy with your duties at several places, you came to attend this webinar, and it is very fruitful and it is very, very helpful to us, sir. Thanks to Professor Pamu Garu giving this opportunity to our college, and on behalf of Department of Physics and Electronics, SR and CVR Government Degree College, welcomes you, sir, and thank you very much for your
One more thing
Thank you, sir.
I just
Thank you,
want to
Ananda.
say. One
And
more
this
thing I
session
just
is
want.
closed for the lunch break.
One second. If
Yes.
any of your
Yes.
students
Yes.
want to come for the summer interns, they are welcome. I can give them all the facilities possible. Only they have to bear their food and accommodation and travel. But in infrastructure wise, whatever if they are required, some interested students are there. They can write to me because the deadline is getting over. Maybe a couple of students, if they are interested, they are welcome. Okay, so you can.
Sir, only PG students and UG students also eligible for that, sir.
UG you can try in IIT Hyderabad and all. PG only IIT Guwahati only takes, because the local state only looks after the UG. Of course, if you still want to, somebody is very keen to do, they are still welcome, but they have to bear financial this thing. That is the only reason. Otherwise, they are welcome.
Yeah. Thank you, sir.
Yeah.
I think
Sir,
all of
sir,
you.
can I get your email ID, sir?
It is
Can we get
there,
your email ID?
pamu@iitg.ac.in. If you type my name in Google, you will get into my website.
Okay.
Otherwise, pamu@iitg.ac.in.
Okay, sir.
Thank you very much, sir. Even all the participants, sir, Dr. Professor Pamus has said that for purpose, internship purpose also, we can utilize their services, and anybody who has students, PG students and scholars may utilize this internship at IIT Guwahati. Definitely, this this is helpful to shine your life. Thank you very much, sir. Thank you once again. And all the participants, this is for lunch break. We will meet at a sharp 2:30. Thank you, Ananda.
Thank you. I'm
Thank you,
leaving.
sir. Yeah, thank you, sir. Thank you very much.
Thank you. Yeah.
Sir, good afternoon, sir. Dr. Pratap Garu.
Good afternoon, sir.
Yeah, this is Dr. Nageshwar Rao, IKC coordinator.
Nice to meet you, sir.
Yeah. So, Dr. Ashirvadan garu.
Hi, sir. Hello.
Good afternoon, all of you. Yeah, today we are going to the last session, that is third session, by Dr. Pratap Kollu garu, Assistant Professor of Physics of University of Hyderabad. And they are also a very nice thesis person in different fields, mainly in magnetic sensors. Today, I request Sri G.V. Gangadharao garu, one of the senior faculty of physics of our college, to introduce Dr. Pratap Kollu garu. Welcome, sir.
Thank you, sir. Thank you, Nageswara, sir. It's very honor to me. Good afternoon, all. Once again, it is my pleasure to introduce our distinguished guest for this section of today's event, Dr. Pratap Kollu, sir. Dr. Pratap, sir, is a professor at the Center for Advanced Studies in Electronic Science and Technology. This is popularly known as a CASEST, which is located at the School of Physics at the University of Hyderabad. Professor Pratap sir holds a significant position in the field of magnetic sensors, designs and fabrications and applications. Pratap sir completed his MPhil and MSc in electronics from Andhra University, Visakhapatnam. He is a gold medalist from the university during his master's course. His PhD in material engineering from Chagnam National University, Daejeon, South Korea. He is a postdoctoral position at 3 universities, which are Tyndall National Institute, Ireland, Indian Institute of Technology, Bombay, Cavendish Laboratory University, Cambridge, UK. He is also a Newton alumnus researcher at Cavendish University of Cambridge, UK, 2016 to 2025. He is awarded the Newton International Fellowship jointly by Royal Society, UK and British Academy, UK in 2013. And he was awarded the Inspire Faculty Fellowship by the Department of Science and Technology, Government of India in 2012. His research areas include designing and fabricating magnetic sensors, prototyping, development for navigation and biosensor applications and 2D material, nanocomposites for energy, multiferrox and water purification applications. He has published more than 96 international reputed peer-reviewed journals. He received Iketani Science and Technology Foundation Award and visited Toyota Technological Institute, Japan in March 2023. He has also received the Young Scientist Award during the 9th International Conference on Advanced Materials and Processing at Northeastern University, China. He has also received the Best Presentation at the CMSC 2021 conference. He was invited speaker at 47 international conferences held in India, China, Japan, Peru, New Zealand, UK and USA. He has more than 96 Sky indexed journals with citations 5000 almost, and H index are 37 and I-10 index are 73. Book chapters are 4 in Elsevier, ACS and Tyler and Francis publishing houses. With these few words, on behalf of our physics department, HOD and organizing secretary and IQAC coordinator, and as well as organizing committee members of the physics department, as well as SRR and CVR college principal, and also colleagues of the lecturers, and also our commissionerate of collegiate education. We are extending our warm welcome to the Dr. Pratap sir. Thank you very much for this giving this opportunity.
Thank you, sir. Thank you very much for wonderful introduction to respected dignitaries and dear students. I would like to just discuss something about what exactly we are doing and what has a scope in science and all this. So I believe you can see my presentation, and let us keep it interactive session. So if you are having any doubts during the presentation, so you are free to talk to me, and I'm happy to answer your presentation questions and all this. So this is just a introduction sort of thing, which should inspire you into research in physics or further studies in physics, whatever it may be. So that's a wonderful introduction. I thank everyone from the organizing committee. So I know your faculty, Ashivadan sir, since long time. I think it is since 2008. I know him. So he's a wonderful person and a lecturer. So he asked me to give a lecture here, and I am happy to be part of it. So that would be great. And this is my title. I believe you all can see my presentation, right? Can you see it?
Yes, sir, it is visible.
So that's great. So we'll start with the presentation notes and all this. So this is how I have framed my presentation. Where are the sensors? Generally, sensors means that the devices which can be used to do the automatic work and all this. So let us go into it. So this is our university, a central university in Hyderabad. So the name of the university is University of Hyderabad, or popularly known as HCU, Hyderabad Central University. And it is funded by Government of India, and we are also Institute of Eminence since 5 years. And this is largely a research-centric university where the courses are mostly in master's degrees. So there are masters in physics, chemistry, life sciences, in arts, humanities, languages, and all this. Even not only after the undergraduate degree. So after the +1, +2, so there are opportunities for students to join for integrated MSc and integrated MA. So maybe I don't go too much into it. If you are really interested, for you or for someone else, you can directly mail me. So this is where we are in. We are in Hyderabad, mostly near to you. We are just 4 or 5 hours away from you. And this is the place where we live in. So the University of Hyderabad is in a mini forest. So these are the images. We have lots of peacocks, deers, rabbits, snakes, wild boars, and we have a check dam. So this is a wonderful place. By any chance, if you want to come here for your internships, projects, whatever it may be, so we can discuss about it, about the possibilities and all this. So this is my research spectrum. I work on GMI sensors, on magnetic sensors. I work on graphene magnetic nanocomposites. We work for batteries materials, and we also work on multiferroids and all this. So these are my research areas. And then I think everybody might heard about this sentence, right? Smart, smartphone, smart device, smart TV, and even you might have heard about smart cities. I think in Andhra, Tirupati, Kakinada, Vijayawada, they are called as smart cities. So can we know why they are called as smart cities? Just by painting, will it become a smart city? So we have heard about smartphones, smart cities, smart cars, and all this. What exactly smart means? Smart means that if you go to your old television, so your old television, which is a big box, so that can play only the movies, news, and the other programs which are directly coming from the cable. That's it. So smart TV means so the TV that could connect to an internet, think about it. So you can play the internet, movies, desired programs. So you can browse the website. So you can go into the messenger sites, and even you can have a pen drive, plug in the pen drive, and then play the choice of your videos, albums, whatnot, everything. So the difference between the old TV and the new TV is the ease of working, which has enabled it, and the facilities which are incorporated in it, and all this. So phones, I believe, have you watched the Nokia 1100 phone? So if the Nokia 1100 phone, so it has a, I think it is of our palm size or less than the size of the palm, and it allows you to make phone calls, receive phone calls, have the send some SMSs. That's it, nothing more than that. And now you are having a phone where you can do everything. So everything means, so you can use it as a computer, draft a letter, make a presentation. So use it for as a meeting device. Means you can open your Google Meet. You can use it as a meeting device. So you obviously you can make phone calls. You can make video phone calls using some of the apps like Facebook Messenger, WhatsApp Messenger. So all these, and even if you go to an unknown place, you can open the maps, use it as a navigation device, and also you can do all your financial transactions using it. So previously, if we want to pay the electricity bill, if you want to book a gas cylinder, so we used to go there, stand in the queue before the company outlet and wait for our turn, pay in cash, and book the cylinder or pay the electricity bill, telephone bill, whatnot. Now I believe that nobody is doing it. 90% are not doing it. So there are few apps which are available. They can be third-party apps or the private company-owned apps, which will enable you to book a gas. HP has a app which will enable you to book it directly. So the facilities that the phone is providing is making it as a smartphone. Means it is able to make some decisions. It is able to do some processing. So it is able to recognize some devices. So if it is able to do some work on its own by using a special devices, so these devices are called as smart devices. So similarly, car. So if you look into your old Maruti car or Ambassador car, so they are generally like you walk into the car, you travel from one place to the other place, whatever should be done for navigation of the car, that is done using manual intervention. So the driver has to do. Means suddenly there is an obstacle. So if suddenly there is an obstacle, there is a big pothole or a big stone, the driver has to apply the brake, then only the car will stop. Otherwise it won't. So suddenly there is a rain. So the driver has to switch on the wipers so that the rain wipers come into picture. But now if you look into many of these cars, so let us compare it with Mahindra XUV 700. So Mahindra XUV 700 has automatic braking systems, automatic driving systems. If it sees an obstacle, so if there is a car in front of it, so if the distance between them is a certain danger distance, the car brakes are applied automatically and it will stop you. So that means there is a small instrument in that car which is doing this process, and automatic rain wiper sensors. So these are the devices which are working on behalf of the driver. So previously the driver used to do all this. Now there are some devices which are doing all this. So what are these devices are? These devices are called as sensors. So these sensors enable us to do some work on behalf of the human being. And when sensors are doing on behalf of the human being, that activity is called as smart activity. And if such sensors are incorporated into any of these devices, so whether it is a phone, it is called a smartphone. Whether it is a car, it is called as a smart car. So So this is all about smart. So magnetic sensors are sensors. They are used in different applications. So that is mentioned here, navigation. Navigation means suddenly you went to New Delhi and you are in Hazrat Nizamuddin railway station and you don't know where to go. Let us say that you want to go to the Parliament building from Hazrat Nizamuddin railway station. How do you do if you have an unplanned thing? How do you do is normally like, so you open your smartphone and open the Google Maps software. Then, so you type the Parliament Bhavan and you try to navigate. So where am I? Where should I go? How should I go? So it gives you the options about what is the mode of transport. So if you go by walk, this is the route and this much time it takes. If you go by bike, this is the route, this much time it takes. And also if you go by bus, so it will give you the bus numbers as well as the distance. So how it is actually trying to do you. So this is a combination of GPS software, Google Maps software, and there are some sensors that are embedded in the phones. So those sensors that are embedded in the phones are 3-axis magnetosensors. And everybody is using computers, right? So there are laptops, desktops, and all this. If everybody using computers, then you are typing a document and you want to save the document into the computer. So when you want to save the document into the computer, so you just click on the save button and it goes and saves somewhere. And after a certain amount of time, maybe after 1 day, 2 days, or after 2-3 hours, you want to look what is in the document. So you will just retrieve it and do it. Do you know what is happening behind it? So how is actually computer storing the data into this the box, and how is the data coming out? So we are not using our hand to place the data, and we are not using our hand to pull out the data from the place. So there is a device or there is a part called as hard disk, and this hard disk stores the data, and for storing there is a head called as magnetic read head. So this is the one how it looks like, this one. So this is the one. So magnetic read heads. So using this magnetic read heads, you write data into the hard disk and you retrieve data from the hard disk. And also, so the sensors are used in biological applications, fake currency detection. So they are used in military applications, oil and exploration. And somebody raised their hand. Please.
1962.
What is your question, sir?
Sir, sometime technical issue maybe. You may continue, sir.
Okay. So everybody is wearing these devices, right? So watches, smart watches, and they are observing everything and all this. So nobody is using smart watches just to look into their time. So you can perform multiple tasks. So you can use them for mail, you can use them for messages, you can use them for listening to music. So you can use them sending emails, you can, so calendars and all this. And also there are few operations that can be done by these smartwatches. So it can measure your heart rate, it can measure your blood oxygen levels, it can measure the temperature of the body and all this. So how it is happening is there are multiple sensors in this smartwatch: accelerometer, biometric sensor, gyroscope, SpO2 means blood oxygen sensors, vibrators, compass, respiration sensors, and all this. So all these sensors combined together is giving you the data about so how you are exactly. So this is where sensors come into picture. And if you look into it, when the scale is moved upon this one, so the lights are glowing. So this is called as proximity sensors. Means when some object is coming near to it, so there is a change in a physical property, and that physical property is causing these lights to glow. So one more type of sensor is called as proximity sensors. And if you go into the kitchen, so might not be in our kitchen, but if you go to a mall, big mall or movie theater, and if you see that, so if you want to wash your hands, you don't need to open the knob. You just place your hands over there or just move your hand across it. So if you move your hand across it, then simply on moving the hand, so the water will flow. So this is where sensors are coming into picture. So then, so you might have heard about smart kitchens, right? So smart kitchens means, so there are few sensors or multiple sensors in the kitchen, which will update your mobile phone about what is happening in the kitchen. So the daily practice of everyone is, so before going to sleep, so you will check, is the fridge door open, is the microwave door open, so did I close the gas valve, so is the water leaking, so something like that. Generally it is a general convention for us to go and check into the kitchen, and we'll closely monitor it before going to bed. This is called as manual testing, and other than manual testing, so it can be also done by sensors. So look here, tap. So provided if the microwave oven is on, so you'll get a SMS to your mobile phone saying that look, the microwave oven is on. You didn't switch it off. So this is the refrigerator. So the sensors in the refrigerator will say that, so is the fridge door open? So what is the temperature of the freezer? And do I need to change the filter for water dispenser over here, and all these. So these are all come under smart sensor devices. Maybe I will not go too much technical into it. So this is what we are seeing. So this is just a demonstration. So if the faucet is running, means the tap is open, so it will show the message that the faucet is running. So if the gas is on, it will show the message either on your phone or any connected device that the burner is on. So if somebody is knocking the door, so it can alert your phone that look, there is somebody knocking on your door. Either you want to open or not to open. So if the microwave is running and you didn't switch it off, so it can display a message that the microwave is running. That is what we are discussing. So how this is happening? How this is happening means there are multiple physical quantities, and these multiple physical quantities can be measured. So they can be recorded and they can be converted into electrical signal. So the conversion of physical quantity into electrical signal is called as transduction or sensing. So if you measure temperature, and if you show it in digital terms, so it is called as temperature sensing. So if you measure sound, and if you show that this many decibels of sound are there, so that is sound sensing. So the same thing, you might have went to hospitals or big malls, and somebody is standing with a gun over there, and they will be operating your body temperature. So that means that guy is using a IR sensor which measures your body temperature. So these are some of the quantities which can be measured, and these can be converted into voltage, current, or charge. So when they are converted, physical quantities are converted into voltage, current, and charge. So you could actually recognize them and record them. So recognizing is important. recognition says that the quantity is present. Recording is also important because you need to say what is the amount of it. So you can say that, look, so I can detect temperature, but I don't know what is the temperature. I don't know whether it is 100 degrees or 150 degrees. That is of no use. So you have to detect the temperature, and also you have to detect the magnitude of the temperature. You have to detect the voltage, and yet also you have to say that how much voltage is it. So because based on the magnitude of the measured quantity, we have to take some actions either to continue or to prevent it. So this is what it is, sensor. Means I have written about magnetic field, but you can use the definition for whatever physical quantity you want. So variation of a physical quantity. So you could detect direction, presence, rotation, whatnot. And if this variation is detected by a sensor, it converts the variation of physical body into voltage or current. And this is the electronics part, which we call it as signal processing. Signal processing is necessary because so you have to identify the real signal. There might be noise because look, if you are trying to record voice of a particular person, so then there might be some other voices around the person, or he or she might be in traffic. So you have to subtract the noise around it, and you have to pull out the original signal. That is done by signal processing. Finally, you'll get the output. Okay. So this one we already have discussed. So types of sensors: direct sensors and indirect sensors. Direct sensors means maybe I think before COVID, when you or somebody went to hospital, so for a fever or whatever it may be, so how did they measure your temperature? Is there anyone here? Do you want to answer? How did they measure your body temperature?
Thermometer by thermometer.
Yeah, great. So where is that thermometer? Where
They
did
used
they?
to keep in the mouth or in the
Under
in the
the
bottom. Touch it. Yeah, under the underarms, something
under
like
the
that.
armpits. So right, sir. That is great. So we welcome such participation, which will make it more interactive. So pre-COVID times, that is the thing. So when somebody goes to hospital, temperature is measured either under the tongue or under the armpits. So this is called as direct measurement. Means based on the thermal contact, the mercury expands, and so it gives what is the body temperature. So of course it is good. We don't have any problem with it. But once the COVID came, nobody want to touch anyone else. That is like, look, that guy, you give the temperature reading to that guy. So that guy kept it in his mouth. I definitely won't keep it. So that is the sort of society which we are living in. Means no offense, but it is fear about our own life. So after that, what are the thermometers you have seen? After COVID, may I know what is the thermometer you have seen in area?
Digital thermometers.
How are they operating, sir?
Without they're using some knobs. They're putting in the ear, or sometimes scanning something.
Yeah, they are using it. Some of them are there. So without touch, somebody is bringing a gun-like device, keeping it on your forehead, and trying to measure the temperature. Those are called as IR thermometers, infrared thermometers. So those are non-contact thermometers. So there are contact and non-contact thermometers. So these are the different types of. So thermometer is a sensor. Thermometer is a sensor which converts thermal energy into recordable voltage or volumetric expansion. So here, what happens is that we are having two different types of sensors: direct, indirect, or contact and non-contact. So this is all about it. So you have lots of sensors in your means wherever it is. So in the washing machine. So in the washing machine, or maybe the better example is lift. So when you go by lift, when there are more than 10 persons, the lift alarm beeps and say that, look, it is overload, you cannot go. So how it is measuring? So it is measuring the weight of the lift, and it is saying that, look, I can't carry more than this. The same principle applies here. Washing machine. So if there are more clothes, the washing machine will not start. So, and also there are temperature sensors in the kitchen, cooktops, ovens, and all these. So they measure a constant temperature. Why? Because so if there are multiple devices in a kitchen and they are uncontrollable, then what happens is that the temperature ranges all of a sudden and there could be blast. So further, what happens is that they attach some sensors into the devices and they'll closely monitor it using feedback mechanism such that the temperature should not increase. So then it is like, so what is it for me? The question is, what is it for me means I don't need to sit before this oven and continuously observe what is the temperature. So it is managing the temperature by itself. So this is a smart device. So if it is having a sensor and internal feedback mechanism and the ability to control its own temperature. Look, I have set the temperature here 200. So if it is above 200, it should have a mechanism to automatically switch off and wait until 200 degrees is there. Or if the temperature is only 160 degrees, it should have a mechanism to increase the voltage and increase the temperature. So then I don't need to sit over there and continuously monitor it to check how it is working. So these devices are called as smart devices. And the smart devices, dishwashers, refrigerators also comes here because in refrigerators, temperature sensors are there and pressure sensors are there, moisture sensors are there. So they control all these devices. So even the same with microwaves and the small appliances. Here in extra, you have humidity sensors to check the moisture of the food. Because if you keep a food in microwave and if it suddenly heats everything, all the moisture is gone, so the food becomes very hard or it turns into charcoal. So force sensors, humidity sensors, all these are there, which are making our life more easier. So these are the sensors at home. If you want to build a smart home, so it's like when you enter in, all the lights should be on and the TV should be on and the fan or air conditioner should be on. So the motion sensors will help you to do all this. So, and if there is no activity over there, so then everything will be off. So these are sensors at home. And we are coming to your phone, which is the most loved one. So there are multiple sensors around it. So accelerometer, gyroscope, magnetometer, barometer, proximometer. So we are saying about 14 sensors. So this data is very old. Now, I think there are almost 30 to 35 sensors that are available in it. So NFC, GSM, Bluetooth, Wi-Fi, whatnot, everything. So these are the sensors which are available. So near field, NFC means even using your phone, just touching your phone, you can make contacts and you can make payments. So you don't need to open your Google Pay or Phone Pay app and do all this. So just by touching and enabling a switch, you can pay, you can transfer some information and all this. So car. So car is the most wonderful innovation. It's like if you talk about the new cars which are available, let us take Mahindra XUV as comparison. So the Mahindra XUV has automatic radar system. We call it as a mini radar system, which controls its speed. Means whenever it senses that the vehicle in front of it is very near to it, it automatically applies its own brakes. So that is the most important feature to avoid accidents. So also it have automatic airbags, cylinder pressure testing, accelerometer testing. So if any person is going, it has to stop. Pedestrian testing. So battery management systems, it controls the speed of the wheel. So automatic rain sensing wipers. So it checks all the engine elements. So it checks the manifold, air pressure, whether the cooling liquid is correct or not, whether the engine oil is there. So is there any oil leakage? So whether the battery is working well, everything. So if you look at the car, means this is called a parking assist. If you don't show your ticket, this gate will not open. So in the metro stations, bus, train, whatever it may be, they'll open. So because the RFSC card is attached to the sensor, and only your ticket RFSC card reads it and it will allow you to open it. So in the office, obviously it is there. Automatic lighting control. When person is walking, lights will on. When there is no activity in the corridor, they will switch off. So they'll save a lot of energy. Okay, so if you go into the toilets, you might have observed it. After washing your hands, if you just keep your hands into the dryer, they'll automatically flush the air. You don't need to switch on, switch off anything. And also, you might have recognized this one. So this is an automatic sensor which recognizes that whether a person is there or not, and it flushes your toilets. So I have given this description, so I'll try to skip it out. So this is about IR sensors in the office, which we are seeing. Because to save the time, I'll switch it off. So humidity sensors. Okay, let me go here. So into the supermarket. So if you go into the supermarket, so there are lots of sensors. Humidity, temperature, light, motion control, and there will be billing. So how do they bill? Do you understand? So you say that there are some barcodes, and the barcodes will help you to bill it. And there are some displays which are called as head-up-on displays. So head-up-on displays will give you the information about what is the material, how do you use it, when is the stock arrived, and all this. So you can, if you show a article which you want to purchase, it will give you the information about what exactly are the details about the article. You call it as eye-level displays. So eye-level displays show the data. So this is not permanent. So you take one object, you want to one product, it will show the information about that product, like the price of it, 0.95 euros. So this is this much rate and all this. So for every object, it will show you the data. So whatever scanning is done, it happens via QR code. So you can look into it.
Latest supermarket scanner developed by Toshiba Tech may make conventional barcodes in supermarkets obsolete. Currently, at most supermarkets, a laser scanner is used to recognize barcodes, but the newly developed object recognition scanner instantly recognizes the merchandise itself, be it fresh produce or packaged goods, by identifying it directly via a camera.
So this is the new type of scanners or new type of billing systems that have been developed. So what we rely on is scanning the barcodes. So you scan the barcode and you know the what is this object and what is the price of it. But the new technology is like it. So you don't need any barcodes, you don't need anything. You just take the object over there. So it will recognize automatically what is the object. So it will recognize its volume and it calculates the price of it and directly gives it. So this is developed by Toshiba, Japan. Okay, so and there are a lot of sensors in the industry which control all this. So sensors are used in agriculture also for crop yield analysis, spreading, water levels, field monitoring, and all this. So these are the sensors that are used in the tulip farms to detect how good they are growing, what is the water level, what is the humidity level, and what are the measures that should be taken if there are any diseases. So these sensors predict and inform or alert the farmer about the crop. So you might have seen all this automatic sprayer systems, cameras that will record the crops, so automatic harvesting systems, drone-based sprayer systems, and all this. So, and also they are used in defense. So there are multiple sensors: optical, magnetic, acoustic, and all these sensors are used in all this. So they are used in avionics, cockpit, flight control systems, and everywhere these devices are there. So smart devices, smart sensors. Okay, even sensors are very much used in satellites. So they are used in hyperspectral instruments, bandwidth instruments, electronic compasses, and deployment machines, payload compartments, and all this. So apart from it, what we do was, I normally do magnetic sensors. I'm going to end it up soon. We use magnetic sensors for navigation, biosensors applications. So we are working with Naval Physical and Oceanographic Laboratory in Cochin to develop magnetic sensors for submarines, for underwater payload and underwater mines detection. And also, because of the confidentiality, I am not discussing about it. So those are different states. So we are working on magnetic biosensors. So magnetic biosensors are simple thing. So if you or someone go to hospital, and if the doctor is unable to diagnose what exactly the disease, how they will come to a conclusion. The only thing they'll do is they'll collect a blood sample or serum, and they will send it for multiple tests, and they'll try to know what is your blood composition, urine composition, and they'll analyze based on those results. So those tests are based on ELISA technologies, we call it as. Those are expensive and they are not portable. So our aim in our laboratory is to develop portable devices such as a pen drive, and which can be plugged into any laptop or mobile phone, and we can diagnose the devices. So that is where we are using these magnetic sensors. And these magnetic sensors are used for detecting diseases like malaria, tuberculosis, prostate specific cancers, and all this. So how you do was, you take the blood sample. So blood sample is conjugated with magnetic nanoparticle. So in biology, and there is a counter biomolecule. So this is called, the red one is called as antigen. The blue one is called as antibody. So in biology, there is a specific bond between antigen and antibody, which is the strongest bond. So if it is a antigen-antibody interaction, then you can clearly detect what is this disease. This is about magnetic sensors. So we are using TMR sensors here. So they are mostly 10 micrometers in size, very small. And this is the TMR. TMR means tunneling magnetoresistance sensors. So we use TMR electronics, LabVIEW, optical microscopes, picoscopes, and all these. So we use them to detect pathogens. Pathogens means disease-causing bacteria or disease-causing virus. So we develop the multi-bit tags and use these tags for detecting the disease-specific bacteria, and you call them as encoding. Encoding means imbibing some script into the magnetic ports like 1000, 10101, and you imbibe the code and make the code to recognize what is the disease. I'm not going too much into it. You can see that this is a very small sensor, the sensor tip, whatever magnetic codes are passing. So it is entering here, it is on the sensor and it left. When the magnetic tag is passing, you can see that the data is present. The sensor is responding to the magnetic field, and this can be used as magnetic sensors and all this. So in our lab, we work on these magnetic biosensors, and whenever there is a magnetic tag, you can clearly see the detection of the signals, and these are biosensor tags. These are some of our sensor applications which we have already discussed. I don't want to bore you with it, so I'll end up with acknowledgement. So he is my PhD supervisor, my postdoctoral supervisor, and he is my principal investigator from Cavendish Laboratory. So I thank a lot to the other funding agencies and collaborators. So with this, I'll stop it. Thank you. If you have any doubts, you're free to ask.
Thank you very much, sir, Dr. Pratap Garu. Now I kindly request anyone may ask any questions, your queries remaining on these magnetic sensors and whatever you have doubts. They are also very well experienced researcher and academician, and hence all of you feel free to ask any questions. If you have any problem to ask questions, you may chat on chat box also.
We encourage you and your students to visit University of Hyderabad for any of your MSc projects, PhD projects. So we normally support the summer projects and all this. So you can visit our place via proper channel. You can approve. So that can be done. And encourage your students for PhDs if they are really interested in it. So if an interesting candidate is there, so you can direct us to the university. We can give them proper guidance and all this. So questions, please. I don't want to talk.
Sir, I have one question, one or couple of questions. Basically, no, I don't. I'm not from physics background, so don't take it as like silly question. Because sensors, magnetic sensors, even though we are using in so many electrons and electric this one, there was some accidents, right? Fire accidents. Like for example, if you take oven. Something like with, so what are the how to mitigate like in future or something like these problems?
So it is like fire accidents will take place.
It's like belongs to short circuit only, or it's like belongs to any other reasons?
Now, every equipment has its own limitations. You should not keep potatoes in the microwave oven. Potatoes will blast.
So
So
mostly you are saying human errors only.
it's mostly human short circuit and no proper servicing of the devices. I don't say that every equipment is a perfect one. So sometimes there could be equipment error, but most of the times they are human errors. So you take the equipment.
Hello.
Sir, I think my connection is lost. I am via mobile.
Yeah, okay, sir. You can, sir. You can now, okay, sir. Yeah. Ravi Kumar Garu, sir is connected. Sir, you complete the answers for that Ravi Kumar sir question.
So actually, they can happen due to the human errors, and also they can happen due to the equipment errors and all this. So there are limitations for every equipment. You cannot rely on overloading the equipment. So if we overload the experiment, that will be a problem.
One more thing, sir, the how to mitigate the radiation effect also, because nowadays we are, as you said, everywhere is there sensors we are using, and to ease the life, human life. So, how to mitigate these issues, so like radiation effects, to from the uh, to protect ourselves.
Radiation control is only in our hand. No one can help it. So if there is a Wi-Fi router in our home, are we switching it off in our before going to sleep or not? That is a simple answer.
Yeah, that's yeah.
If you
Whatever
don't,
we have in our hand, we are doing. But for example, there is cell phone towers are there that we can't avoid. We can't go
that you can
because
avoid, sir. That is all about self-control only. If one company is giving a person 1 lakh rupees, he or she is allowing to use it on their building top. So that should not be allowed. The cell phone towers should not be on any building premises. They will create a problem. So it is all about collective wisdom and human control. So if one is greedy, we have to face the consequences. So if we switch off all the Wi-Fi routers, night will be really awesome. You can sleep well. But if not, that will be a problem. So it is all about how good we are. So the only thing we do is we blame on others. We blame on someone saying that that guy is doing that, this guy is doing this. So first of all, what we are doing is the most important thing.
right.
Yeah, thank you, sir. Dear participants, the feedback form is kept in your WhatsApp group and also on chat box. All of you, please fill this feedback form to get the e-certificate. Anybody, please respond. Any queries? So thank you, Pratap sir. I think question answer session may be concluded. And today's beauty is that three of the resource persons are came from government schools and colleges. That is the greatness of government school education and government college education, who are into the very, very nice resource persons we get today. One of them are from South Korea, Ulsan University, and the second one is from IIT Guwahati, and third resource person is from Central University, Hyderabad. We are very, very lucky today, all the participants who are there. Now I request Sri Devendra Reddy Garu to propose vote of thanks.
Good afternoon, all. Myself, T. Devendra Reddy, lecturer in physics, SRR and CVR Government Degree College, Autonomous, Vijayawada. I'm ready to propose a vote of thanks. First of all, on behalf of Department of Physics and Electronics, SRR and CVR Government Degree College, Vijayawada, we thank Dr. Pola Bhaskar Garu, IAS, special guest Dr. C.H. Krishna Sir, Joint Director, CCE AP, for allowing this webinar. We are thankful to our respected Principal Madam, Dr. Bhagyalakshmi Madam, permitting and kind support for smooth conduct of this webinar. We are extremely thankful to Professor Ravi Kumar Sir, Adjunct Professor and Principal Scientist, Changwon National University, South Korea, for delivering a lecture on intumescent flame retard nanotechnology for heat resistance in high-raised commercial towers. We are also thankful to Professor D. Pamu Garu, Department of Physics and Center for Nanotechnology, IIT Guwahati, Assam, for inspirational talk and innovative talk on nano ceramics and thin films for electronic devices. We are grateful to Professor Kollu Pratap Garu, Center for Advanced Studies in Electronic Science and Technology, School of Physics, University Hyderabad, for his valuable lecture on magnetic sensors, design, fabrication, and applications. We are also thankful to Srimati P. Shailaja Madam, in charge Department of Physics and Electronics, Dr. J. Nageshwarrao Garu, IQAC Coordinator, Dr. B. Nagamani Madam, Srimati T. V. Vakulapriya Madam, Dr. A. Ashirvadam, and G.V. Gangadhar Rao Sir. Especially Gangadhar Rao Sir provided this technical support in organizing this seminar. Thank you, sir. We thank all research scholars, students, and faculty from other colleges and departments for their active participation and cooperation. Last but not the least, we are thankful to our non-teaching staff who provided their support in organizing this webinar. So I am thankful to Shailaja Madam, in charge Department of Physics, for giving me this opportunity to propose vote of thanks. Thank you, one and all.
Yeah, thank you very much, all of you. Please don't ignore. All of you must submit feedback form to get the E certificate. You get a E certificate will be sent very shortly. Thank you, one and all.